just gonna. All right. We are live.
Hey everyone, we are here again in the first week of our Build and Brew hackathon. We started that this Monday with our opening ceremony. My name is Mariana. I lead ecosystem growth here at Espresso, and here we are with Wheat. Wheat, you want to introduce yourself?
Hello, everybody. I'm Whit. I lead product marketing at Espresso. We are excited to kick off this kind of. Well, actually, it's not the first because we did do a workshop earlier. One workshop earlier this week, but excited to kick off this series of technical workshops for all the devs participating in this hackathon.
Yeah, I think something interesting to note is every builder that is with us in Beauty Brew could come to the workshops. They're going to have a lot of resource needed to start building and doing their project, but also like if anyone is just like enthusiast on the space and is looking to learn about building cross-chain apps, I think this is the right place to be. So just keep tuned. The session is being recorded, so we're going to be also posting it as a playlist in our YouTube here in Espresso. And to kickstart here, I would like to thank our partners who is helping us with so much things from like additional bounty price to office hours, workshops, marketing communications, brain power, brain dev power, and everything. So super thanks for Hyperlane, Across, OpenZeppelin, BootNodes as interop partners or just infrastructure partners. Also thanks for like Infura or RPC provider here in the hackathon, Off-Chain Labs as our ecosystem partner, and AWS as a cloud provider as well. For today's agenda, we have this full schedule with different all these partners coming to explain different pieces of the puzzle. First, we start with like reading from Espresso Network with Jean. Jean was here last Monday, so now he's going to be explaining. Monday, you learn, like in the open ceremony, you learn how to deploy Arbitrum Nitro rollups, integrate Espresso. Now, from that place to here, we're going to learn how can I deploy a caffeinated node, read from these nodes, and be able to then build these cross-chain apps. And for this, we're going to give an example of a wallet train alert bot. After this, we have Infura with Gabriel explaining about automating rollup deployment with GitHub Actions. So pretty much like best practice on smart contract deployment with CI/CD. After we have Ida from Hyperlane explaining and going a little bit more in details on the open intents framework, what they are, what are intents, why do they matter, why do they make cross-chain development easier. After this more intro approach, we have BootNodes going more down the route of deploying and building. So we're going to have a deep dive in how to build with the existing repo on the open intents. Then having all these toolings, we go with OpenZeppelin about let's design cross-chain primitives. What you should have in consideration for building your multi-chain app. And lately, and lastly, but not the least, we have Across explaining and showing how to build cross-chain apps with Next.js and Across SDK. So it's a full agenda, full schedule. I hope you stick with us until the end. But if not, again, sessions will be recorded. And I pass to Wheat so he can present our first speaker.
Awesome. Yeah, we are going to hear from Jean, who's a software engineer at Espresso. And we, this is a lot of this hackathon is all about cross-chain apps. And he's going to walk through one use case that is enabled by integrating with
Hello.
Oh, there he is. All right. Yeah, go ahead, Jean.
Hello. Hello, everyone, and welcome to the second Espresso workshop and the first workshop of the day. The first one was on Monday during the opening ceremony. And this kind of workshop, this workshop is going to be an extension of the one on Monday. So by the end of this workshop, you'll have all the knowledge you need to be able to start building your own project that benefits from the Espresso network and that is able to read parse transaction and do something out of it. And so in order to do this, you're going to know how to learn how to deploy your very own caffeinated node, CAF node. So in this workshop, these are the steps that we are going to go through. pretty simple and straightforward in the names, but like project overview of the little application we've built, some of the prerequisites, what exactly is a caffeinated node and why do you need it, some of the setup instructions in order to get it running up and running. And then same thing with the example project, so tweaking with the configurations for you to be able to take advantage of the caffeinated node which you've deployed. Then there's a specific section of troubleshooting. We'll go over some of them. We'll very quickly go over what updates you need in order to, well, not run everything on the testnet, but have it running on the mainnet. We'll also go over a specific section on how to, well, deploy your caffeinated node on the cloud, so not only locally, but keep it on EC2 instance, kind of similarly to what we've done in the first guide, which we've broadcasted on Monday. And in the end, we'll do some tweaks to the monitoring application for it to be able to properly be calling the caffeinated node, which is running on the cloud. So quick project overview and what we're actually going to go over. The idea of this application was just to show you how you can benefit from the caffeinated node in order to parse transactions. So we've built this small Go-based application that is going to monitor the Espresso network through the CAF node and monitor specific transactions that could be suspicious. So let's say, for example, you want to make sure that one specific address doesn't get all its fund removed at once. So you can tweak it and tweak the application to, well, be able to detect and log wallet drains, for example. So project continuously read and parse transactions and then filters these transactions based on specific values, and then will alert the user. Let's say, oh, we've detected this specific transaction. All right. So in terms of prerequisites, which I've kind of mentioned before, you need to have gone through the guide, which is deploying an Arbitrum Nitro rollup integrated with Espresso, which again we've seen on Monday. It doesn't mean you cannot follow this guide through with us. It's going to be very helpful and everything, but in order to you're on your own run all of this, you will need to have your own Nitro rollup deployed. And so as a matter of fact, we're basically using the same repositories. So Espresso built something real, which has the configurations to deploy and run your your rollup. And same thing with the hackathon example, which we used to basically, in a specific branch in the previous guide, read transactions from Hotshot through the query API. The only thing is we used to not only just get bytes, but not really able to identify anything about these transactions themselves, which is why we extended as well in the same project right here. And so just to give you a little order of how things happen and what exactly is a caffeinated node. So think as the top part, basically the same thing as we've seen in the previous guide in the idea. So you send as a user transaction to your rollup, which goes to a sequencer batch poster to the Espresso network. Well, in our case, consider the caffeinated node as being this JSON RPC node, basically for that specific rollup. So you specify, you set it up exactly specifically to be connected to the rollup you've deployed, which is going to read the Espresso network for that specific rollup and be able to, well, you'll be then able to do any kind of RPC rollup calls you would make generally, but to that specific caffeinated node. And so you as a user will be able to, well, get transaction status like the sender, the value, the destination, and all of these things. So now that this is said and done, I hope this makes a bit more sense to you. Let's just get started. All right. So these are small indications that you have all this information. So first of all, is the Espresso build something real repository when we're going to ask you to update the configuration? So pretty straightforward. Is kind of similarly to the full node and all the information we had. There is this new folder right here called CAF node in the configuration. And so go on this cafnode.json. I hope you can see properly. And so update the specific values mentioned in the guide. So we have here the chain ID, which is going to be the same thing right here as the namespace, which is the chain ID of the rollup you've deployed in the first guide. Here we've got the hotshot URL and Espresso T verifier, similar to the full node for testnet. So you'll see the equivalents in the mainnet section for doing all of this on the mainnet. Two important parts are WebSocket Arbitrum, Sepoli RPC URL. So your RPC provider URL plus the API key, slash the API key. So depending on which RPC provider you decided to use. As you can see here, it mentions the sequencer URL of the Nitro node, which is on port 8547, which we've seen in the previous guide. You do not need to modify, but it shows you that the CAF node is also listening to the rollup which you've deployed. And last thing is this specific next hotshot block. So basically, this is going to specify the block to the point where at the point where your CAF node is going to start syncing, right? So if you forget to update this value, let's say if you go to the Explorer, so we have the Explorer address in here in the guide, all right? But if you go to the Explorer address here, you get this specific hotshot latest block value. As you can see, it can update very quickly. So make sure that when you run Docker Compose up and build your container, you update the specific values, because otherwise your caffeinated node could take a lot of time to resync all these blocks to the point you've mentioned here. So every time you run the container, update the specific value right there. All right. Perfect. Okay, now this is said, an addition thing you need to do, like I've mentioned previously right here, your CAF node is kind of listening to the Nitro node itself. So you need to provide as well the configuration file of the L2 chain info. So this value which you've updated in the previous guide with all your addresses and all of that, you can find it in the first guide. Well, you just copy this L2.chainInfo and copy and paste it directly in the configuration right here. So similarly to the way architecture is done, so the repository, so full node L2, here you have CAF node and the L2 chain info. And additionally, you're going to want your caffeinated node to be listening to the same state, to the same database as your rollup. So we've specified in the guide. Make sure that before doing so you shut down the container of the rollup. All right, then you copy the database folder right there and paste it from the in the CAF node directory. So let me show you in the code itself right here. So you have this database folder right here. Well, copy it when the when the container is down and paste it in the CAF node folder right here. This way, the caffeinated node and the rollup will be exactly in sync and will be able to run concurrently. All right, and so once this is done, I'm not going to show it to you right now because I did it on the cloud and it'll be easier when I show it later. But make sure you first of all go in the main folder, you run Docker Compose up, and then you navigate in the CAF node and you do the exact same thing. This is first gonna deploy the rollup and then deploy the CAF node. So all these steps are mentioned right here. Docker Compose up, Docker Compose up. You can do a little -d if you wanted to, if you don't want the logs to be directly in the terminal itself. All right, so if you followed all the steps, it should work perfectly. If you come across any error, go to the troubleshooting section. We'll go together on it. But basically, once this is done and you have it up and running, then this is when you're going to set up the example project. So example project is in the, like I've said, hackathon example under the main branch. What is actually important very quickly, this is, I'm going to just explain for the sake of it. We're using this specific Go Ethereum version to be able to, well, call the functions we want and everything. So we made sure that we just download the submodule, so everybody starts with the same repository and you don't come across that many errors. This is why we've specified all those steps here to install the dependencies. All right, so submodule update and everything. All right, so the important part we are interested in this repository is this config file. And so in this config file, we have the config.json. So in the config.json, we have those specific values which we've mentioned. So here is going to be your host. So basically, if it's on the local host on your computer, local host, otherwise the IPv4 address. Same thing here. So you have the value at which you want to be alerted. So let's say if it's just some simple, easy transaction, don't mention, but at some point you'd be like, oh, well, if a transaction from this address, which has like more than, I don't know, 2 ETH, which is a pretty big amount, no matter the price, well, notify me. So for example, in my case right here, we'll start with 20, and I've actually deployed on the cloud to this address, so I've replaced localhost with this address, and this is the specific address I want to be monitoring. All right, so we'll go over this in a second. All right, so update these configurations. There's all the information which I've mentioned right here that are important. For example, value amount is in way. Let's say localhost if you're running locally, blah, blah, blah. So all the information that you need in order to do this. All right. Now, okay, we can basically run it right now. I mean, it's on the cloud. I'll go over it, but we can just do go run. Now, the thing is, it's going to tell us that the application is getting started. So starting the application, searching for a transaction at a process block. Now, the thing is, if we go here, then we need to be able to send transactions, right? So there are multiple ways to send transactions. The following ways are either to the command line right here, to the specific command line. So here, don't forget you send transactions to the rollup, not to the caffeinated node. So either this or the URL, the IPv4 address with this specific port, or you use the transaction generator, which we've seen in the first guide, and then we're going to go over quickly together right here. So if you see there's this transaction generator folder, you go to the index file, and here you have the Rollup RPC URL, so localhost 127 whatever, or the IPv4 address. You see same again sending to the Rollup with destination address and signer, which is basically the from address that we're monitoring from. All right. And so in our case, let me show you very quickly, 2 seconds. I'm just going to go in the log groups, and so we can actually see what's happening. So I'll go over it in a quick second how it happens, but let's say we go to the Nitro node, which is actually running, and here we go to the CAF node, which is also running. So this is getting the logs on AWS. I'll show you how to do it in a second. Right now, let's say we are listening right here. We've set the value to 20. I'm sending 15. Right, I'm sending a transaction. Where was it? No, it was actually here. All right, you see, I'm sending transactions that are of value 15. Let me send another one. And then we wait the signal a few seconds, and you see that, well, awesome, we've sent a transaction with value 15. Now, if we go on the listener right here, well, you see it didn't find a specific transaction, right? However, if we go on the logs, right, and we check at what was going on, and we go down, so 827, let's go down, and we see here, added message to queue 515, right? And same thing with the rollup logs. If you've already did the first part of the guide, you should see. So yeah, enqueued pending transaction to Espresso was successful for position 515, right? So you see it went over 515. It didn't see any it went to 16 and now it's looking for, so which means that it didn't notify our alert specifically. Now, if we stop it right now and reduce this value to, for example, 10 in order to be notified, let's run this again and see what happens. So we'll wait for the application to start. So the application started, and you see it found the previous transaction which we've just done, which was like for latest block 516. You see, because actually I didn't stop the transaction generator, which is why we have sent a lot of transaction, and which is why the the hackathon example repo was able to find all these transactions that are quickly being processed, which shows us that, well, everything is working perfectly like we want to. Now, awesome. Now that you get an idea of how things work, I'm going to go a bit over the cloud deployment section, right? And what we really need to understand in that specific case is, not now exactly. We'll first go to some of the troubleshooting and explain some of the messages. So if you've seen right here in the logs, you get a lot of these specific messages: failed to fetch, error while getting, blah, blah, blah. This is for the CAF node itself. Well, the thing is, considering the CAF node processes, tries to process block at a very high speed, well, it doesn't necessarily find a block every time, which is why you get a lot of these log messages, but doesn't mean it's a specific error that and your code is not working, right? So which we kind of see right now. Same thing is if you get to transaction detection messages. So this is mostly for the caffeinated node, but you're supposed to see added message to queue for a certain message, which we've actually seen. And then you can at some point get to this step which says produced block, blah, blah, blah. So if we see when the transactions were sent, that was probably very low. Well, at some point I need to find the messages themselves, but you should see, so initial state, last block app, produce block. So this means that it's actually running up properly. Awesome. Next things you can find and come across is the specific no transaction found, blah, blah, and you get these messages at a very, very high throughput, right? And the reason is, this is because you have not updated the next hotshot block from the Espresso Explorer. And so if you forget to update it, then it might take a very long time to resync with everything, and at the same time be burning through your RPC requests. Awesome. Next little error you can you generally come across if you restart both Docker containers. Sometimes it happens that, well, the database get out of sync. So make sure that you put up to date your rollup, close the container, copy paste the database folder, and then rerun everything smoothly, and it should work. So I've mentioned right before in this section right here the number of RPC limits. Keep in mind that these are some of the polling intervals that allow you to kind of be flexible in the number of RPC calls that are being made. Bear in mind that the code is very, for the Nitro Arbitrum code is very RPC heavy. So it may be that you be spend like burning kind of through some rate limits. So, and actually other way around, if you have an advanced plan and you want to have it more than production ready, so, well, feel free to even reduce those intervals. It's up to you to kind of work on the architecture and where how you want your rollup to be running, right? And so these can be found in these both specific config files. All right. And last thing is monitoring issue. Like we've seen right here in this part, it was saying searching for transaction at last process block 516. If you do not see that specific value right here, it means that, well, your RPC node is not properly set up, or it's the database is in the wrong place, or whatever the structure is can be wrong. The idea is you need to be to potentially recopy the database and everything, and we've added some of the solutions right here. Right here is update for listening to mainnet. We're not going to go over it right now that much, but just mind that this is the information that you need to update. So we're just indicating you. Some of it is already in the previous guide, which made accessible right here, but we're not going to go over it now. All right, so in this specific section, which I was about to tell just before, so for deploying your caffeinated node on the cloud, basically we're trying to reproduce the exact kind of repository structure we had in the Espresso build something real repository, which you've seen here, right? So in the previous section, we've shown you how to deploy your rollup on the cloud. Well, now the thing is, we're actually gonna, through all these steps in the guide, be creating this CAF node directory, right? So, like for example, first thing, you're creating the database config wasm inside CAF node. You're giving the corresponding write access for your rollup to be updating the database and CAF node from inside the EC2 instance, and then here, like you see, transferring the configuration files, running the copy pasting the database like I've mentioned before. Same thing from inside of these the instance if you want to, and so this will just reproduce the exact same architecture repository structure you had. And last thing is the enable CloudWatch logging. So CloudWatch logging is the section I was mentioning right before when we seen the CloudWatches here, because it's instead of having like everything running locally on your computer and probably taking a lot of processing power and all of that, you could directly do it in the cloud and then go and see the logs in the cloud itself. All right, so basically in order to do this, well, you need to create some log groups and stuff, which is similar to the previous guide, which is linked here. But basically, what you need to add is this specific logging section, which I've actually commented out right here. So you can add this one and change the name of the region depending. I'm in Eastern zone, so this is why. But like depending on where you are in the world, you can change this specific region. And if you have created the proper log groups and everything, when you're going to run Docker Compose up, it's going to link to CloudWatch if you followed all the steps that you can see in the previous guide. So do not forget to go over this. Awesome. And so last thing, if you did this, then you've modified the Docker Compose file, you move it to the instance in the proper location, and then same thing, Docker Compose up in the rollup, Docker Compose up in CAF node. So same with some information and stuff that you might find useful when doing the procedure. All right, and so last thing is, as you can see right now, we're actually doing calls to the CAF node, which is located in the EC2 instance. So you may come across, if you didn't specify the proper security rules, you may come across some errors with regards to accessing certain ports of your EC2 instance that you want to be like exposing. So let's say let's go in this EC2 instance. So let's say you have your specific instance which is running. So you actually click on the instance ID, go in the security tab, find the security group, and edit the inbound rules right here to be exposing those ports such that you can do custom TCP requests to these specific ports. All right, so that should be it for as a building blocks and all the tools and the steps you need in order to start reading transactions from Espresso, building applications that can actually do something about it. So in this specific Dora Hacks, in the Dora Hacks hackathon page, there is this ideas to build tab with some of the ideas. Is just some indications that can help you to get an idea of what you can build upon and upon this application extend. So one, for example, that I can go over is, let's say, for example, you have an NFT marketplace and you want to make it cross-chain. Well, the idea is, well, if you mint your NFT on a Rollup A, which is integrated with Espresso, if you have your caffeinated node, which is listening to that specific Rollup, well, you can take advantage of these fast confirmation that you get in a couple of seconds from the Rollup A, such that your app can actually mint the NFT on the Rollup B without having to wait for L1 finality and avoiding reorgs and all that kind of things. So this is just an idea of how things can be extended. You can find other things if you have, or even ideas you may have. This is up to your freedom and to decide and be original and all of that. But it was just to give you an idea of it. All right, so I hope this was clear enough for you and that you have all the necessary information and steps to be building super cool application and use cases. So enjoy the rest of the workshop talks this afternoon, and take care, everyone. Happy coding.
Awesome. Excellent. Mariana, we're back up on stage. Did you have a question for Jean?
Yeah, I think we need to bring Jean back to the stage.
Jean, you want to turn on your camera and mic? Cool.
Yes, can you hear me?
Yes.
Yeah.
Jean, the question I have is more like in deploying the caffeinated node. Can you explain for someone that's like a dev that never deployed Rollup before, if they should be doing this for all the rollups they deployed? In each case, they would be deploying more caffeinated nodes. And what is the main function of a caffeinated node?
Yeah, basically that's what I was trying to explain at the beginning in the early section. The idea is that each caffeinated node is specific to one rollup that you're deploying, right? So as you can see in the for example logs, the caffeinated node is simply putting out this kind of RPC. It's basically this RPC node that allows you to do calls to this rollup integrated with the Espresso network. So if you want to build different rollups and get to listen from both sides, then you would have to deploy one CAF node itself per rollup. And I hope that answers your question.
Yeah, it answers. So basically, if you're reading from Rollup A, you need to have deployed a caffeinated node on Rollup A. But if you need to do the opposite, that is reading from Rollup B, you also need to like deploy a caffeinated node on Rollup B. That is normal, like how we read transactions, interact with the nodes of a blockchain.
Yeah, and also depending on the kind of let's say application you want to build or kind of cross-chain interactions, maybe in some cases you would only need to have one rollup that is that you're listening to get those fast confirmations. So it really depends on the kind of use case you want to build. If you want to do bi-directional communication, then it would be best to have deployed 2 CAF nodes. But yeah, in the idea, that's exactly this.
Yeah, for a hackathon, I think like if you're just doing a hackathon project, depending the level of like complexity you want to bring in your cross-chain app, would make sense to deploy 2 caffeinated nodes. But like for the sake of like the understanding of the action, I think 1 caffeinated node can do a lot of the work. Thank you, Jean. Thank you a lot. I don't know, Wit, if you have another question. If not, we can go to our next speaker.
Cool. Yeah, so thank you very much, Jean. Yeah, we are going to get now Gabriel from Infura. He's going to talk about automating rollup deployment with GitHub Actions and how to automate smart contract deployments with CI/CD. Let me get him up on stage. Here he is. All right.
Hello, can you hear me?
Yes.
Yeah, I can hear you fine.
Awesome.
Bringing
Awesome.
up
Cool,
your
cool.
live stream. Here we are. Cool. And going to remove Mariana and myself from stage.
Thanks for being thanks for being here with us, Gabriel.
Yeah,
Yes.
no, definitely.
Running the hackathon as well. Feel free to, in any moment, direct like people for the links of Infura that they might need, or even the guide that we provide to any hacker to have access to developer tier. Thanks a lot.
Absolutely. No, happy to sponsor this. This is great. I think it's great to see kind of the activity that's going on and the evolution of on-chain development. So I'll talk a bit more about that earlier about my background, but all this L2, L3 stuff is really interesting. So happy to sponsor it. Cool. Can you hear me fine? Everything good? Looks good?
Yeah, I'm gonna remove myself here as well, Wheat, if you can just let Gabriel on the stage.
Yep.
Sounds good. All right, I'll jump in. Cool. All right, so I'm gonna go through, and it's a good segue from Jean's presentation. I actually went through the guide. So I'm a product manager, and if I was able to get through it and actually deploy Rollup, I'm sure the hackers should fend well with that guide. So with that, I'll jump right in. So at least for my segment specifically, I'm more interested into how you actually leverage that Rollup that you're actually going to be deploying, and how you start interacting with it, how you start building applications on top of it, on top of those Rollups. So with that in mind, so I'll give us a quick context about me and about who I am and why I'm here. Some CI/CD principles that I think I hope are all helpful in your journey with the hackathon and with Espresso. Then conceptualizing some contract pipelines, and then I'll give you a hack tip. And I hope it's helpful, and it drives some interesting projects at the end of the hackathon. So let's jump right in. So my name is Gabriel. Call me Gabe, it's shorter. I'm a product manager at Infura and MetaMask developer. So if you haven't noticed, Infura is now a SIP product under MetaMask developer. So we're looking to do a much tighter integration between wallets and infrastructure. And so at least in terms of my background and why what I'm going to be talking about is relevant. So early in 2017, I was working in a big large scale smart contract project for a bank. So we were basically developing or simulating credit default swaps on an Ethereum-like blockchain, and I had to develop a custom smart contract framework, very similar to what we have today, like in terms of a Foundry or Hard Hat. And this was a very early on version of Solidity, so version 0.4 I think it was like 17. So I know a lot of the pain points of developing smart contracts. Back then, this was a private ledger. Now we're talking about L2, L3 rollups. So, really interesting stuff and how things have evolved. So with that, I will jump right in. So also a reminder, we also have a coupon, Brew 325, in case you need a RPC provider with MetaMask developer / Infura. As you go through the process of onboarding and you want to get a higher developer tier, it'll be free for you. For the hackathon, so feel free to leverage this coupon when you're signing up, or if you already have an account, you can feel free to upgrade. All right, so setting up some context before I jump in, and apologies, I won't be doing live code. I've been having issues with my computer, and I think the code setup I have right now is a bit fragile, so I'm not sure if it would work, but nonetheless, going through kind of these criteria of what I'm going to be talking about. One of the main objectives of the hackathon, right, is deploying to decaf, right? That's we got to get this done. We got to get it done properly. There's I think another workshop after mine that's around the open intents framework. So really interesting and very relevant to what we're going to be talking about, because as you're developing on open intents, these are smart contracts. You're going to be iterating on them, and so you want to have a really good, solid foundation for actually, having a repeatable process to deploy and test these contracts on Rollup. And then lastly, Rollup verification. So making sure that the Rollup is actually live and working, and perhaps someone can actually even use it. And at the end, I'll give you kind of like a hack tip in terms of how you can get this done in case you have issues with AWS and setting things up. So with that, I'll jump into some CI/CD principles. So I'll go through some 3 principles that I typically kind of have leveraged in the past, and in my experience developing some of these things regarding CI/CD and contract development. So use boilerplates. So don't start from scratch. Sometimes, as developers and engineers, we get too curious and we want to start everything from zero. Hackathons, we want to move quickly. We want to show results as quickly as possible. So leverage a boilerplate. And my recommendation is ETH Scaffold 2. I actually went through this yesterday. I set it up, interacted with the Rollup. Everything went well. So I recommend this. It has everything that you need. It even has CI/CD pipeline set up for you. and it has a ready-made front end for you to start interacting with those Rollup contracts, and also has a wallet connectivity in case you want to have some nice demos at the end of the hackathon. So the other piece is automation. So if you're probably going to be doing something more than 3 times, definitely we want to make sure we can automate it. So one of the things that as I was going through this, it was like we have to have this is basically deploying to that local rollup. So basically set up your hard hat, or if you have Foundry setup, whatever it is that you're using, set that up at least. And I have a repo that I can share afterwards. But basically this is my network setup for actually being able to interact with that rollup, which is basically local host at port 8547. And so with that, you can actually start, with your whatever smart contract framework you're actually interacting with, you'll be able to deploy contracts and interact with that local rollup, which is basically what we saw in the previous workshop with Jean. And so a quick tidbit on this, actually, that I had issues if you're working on a Mac, is localhost wasn't working for me. So you have to use, the actual IP address for localhost, which is 0000. Cool. So that said, and then the other piece is, it's fancy and appealing to automate things, but just make sure it's working locally before you actually go out and put any of this stuff in a pipeline and GitHub and start working in some of those GitHub actions. So at least for me, so I was able to actually, configure that smart contract framework and deploy some of these test contracts that come pre-baked into the the scaffolded project. And so was able to, get up the rollup, deploy some of these contracts, run some tests. So, you should be, this should get you up into a good framework so that you can, start developing and iterating with whatever application you'll end up developing for the hackathon. Cool. So I'll be moving on. Let me just check here. So conceptualizing contract pipelines. So as I mentioned previously, I have some background on this in the past. And so, the way I think about this, it's 2 terms, right? So continuous integration, continuous deployment. So you want to do the continuous integration to make sure that as you're moving new code forward, you're integrating that into the code base with high confidence. If you're in a team setting, this is extremely important. So you want to make sure that you have this set up so that as different people are contributing to the code base, you're not falling behind on different pieces of code, different pieces of functionality. And so that's why, you want to get this done early so you don't face issues, especially at the end of the hackathon when you're kind of scrambling to connect things and get things done and everything's failing. And then continuous deployment, this is actually, it's not something that's oftenly done in smart contracts, but it can be done. And it's once the code is, you have high confidence, it's been tested, it's integrated, you see these pipelines are always green. We feel good about deployment and about deployment quality. There's this comment I had about deployment and delivery, at least in smart contracts, is really deployment. We're not delivering packages here, so I have to get into it. Contract integration. So a typical pipeline looks like this. The scaffolded project actually comes with something very similar to this already, by default, where you have like a lint build test type of phases for those smart contracts in that project. And then at the end, there's like this deploy piece, which you can be flexible. It could be on that hard hat node or Foundry, I think it's Forge, that you can actually deploy these contracts and test them if you'd like to add this to increase confidence, especially if there's like interactions between different instances of contracts. And then continuous deployment. So, I think we can get creative here and actually do this from GitHub Actions. At least for this hackathon, is as you end up in this deploy phase, you can actually deploy to either testnet or mainnet. Most likely testnet can be automated. For mainnet, I wouldn't recommend actually automating something like this. And this is something that typically will happen offline. But if you get there, kudos. I think that would be wonderful and impressive, because deploying to mainnet is not light. All right, so this is kind of the scaffolded CI. So if you adopt the scaffolding of this project, you'll basically get this out of the box and you can modify and edit it. I modified some of the some of the files to get this done in a cleaner way, and also to work with my deployment locally. But yeah. And then one last hack tip I want to offer is that if your AWS deployment gets complicated for a variety of different reasons, AWS is complicated in general. So setting up infrastructure is not a light thing to do, especially for a hackathon. There's costs involved, there's configurations involved, etc. Something that you can actually do is you can implement some tunneling with ngrok. So this would actually allow you to, from your CI/CD or from UIs, be able to interact with your Rollup or your smart contracts in your Rollup from externally. So this would be great for you from a demo perspective. Hackathons are typically always about the visual candy of what you can show, and obviously with some of these infrastructure components in mind, you want to make sure that you have that set up locally working fine. If it's a testnet or even mainnet, locally should work fine. But with ngrok, you can focus more on Espresso, focus more on the hackathon, rather than necessarily focusing on mangling AWS and infrastructure problems, which is sometimes not easy to handle. And then some visualization, right? So if you set up an ngrok tunnel, you can basically deploy from your CI/CD. If you're working in a team, I think this would be a great addition, because that CI/CD pipeline, one person in the team can basically focus on hosting this stuff and managing the infra, and then the CI/CD pipeline can actually tunnel the interactivity to the rollup and interact with the rollup. And you can actually also have like a UI, say on Vercel, for example, or on any other provider that interacts with that rollup, and you can also focus on things there. So with that said, I think I should be done. I can open it up for questions. I believe space for 1 or 2 questions. So that's kind of my part. Any questions for me?
Yeah, absolutely. Can open it to questions if anyone has. We do have one comment that we got someone saying thank you. This is what he's been looking for. He's been looking for CI/CD use cases for smart contracts. Nice. That's good. And awesome. We'll certainly have this video up on YouTube as well for everyone, participants to view after the fact. If they do have questions, I'm not sure if the full schedule, but I know that we'll be hosting some office hours, and I'm sure if there are questions specific for you that we can reach out. Are you on Twitter? Do you want to share your handle or anything like that?
Awesome. Yeah, I have a Twitter. I'll also be on the Discord. You can typically find me as Smadi. I'll drop it in the chat or. So if any questions, I also went through the Rollup deployment, had some issues as well, but so if anyone has any questions on that, I can certainly help. Awesome.
Oh yeah, for sure. And there's a little banner. Got your thing up there. That's how people can reach you. Awesome. Cool.
Hey, Gabriel, I have a question actually. First, I think it was a great short but very concise way that developers can just like start building faster. But as a product manager mindset, going beyond like it's very different the way a developer approach things from a way like a product person approach things. How was it like knowing the intents and the 2 tracks on the hackathon, knowing that the first track is more about like, okay, learn how to deploy a rollup, and here's like even some toolings for you to make it like a little bit more optimized, but going to like tracking composability, how you with like a product mindset would go for it?
Yeah, it's okay, hear me. It's a good question. I think the composability, so there's 2 tracks, right? The composability and the intents framework integration. I think and we don't see too much about on this yet in the ecosystem, so I'm really excited to see some of these particular applications about how you actually get some of these different chains, different rollups to interact with each other, and what particular applications might there be. So at least something that it goes back again to some of those early experiences that I had in my early days working with blockchains is so this permissioned ledger that I used to work on, it had this this kind of privacy, I would say. They were like very similar to rollups, and you could actually interact from contracts from one rollup to another. So I'd be curious to see applications on this end, like how you get these like contracts between chains interacting with each other. Does that answer your question?
Yes, I think like you got from a place of curiosity, and I would love like also a place from a problem.
What was that?
I would love to see something coming from a problem that you see.
Oh, I see. Oh, definitely. Yeah, yeah. Use cases. Absolutely. Yes,
Exactly what
yes.
you mentioned comes
Yeah.
from a place of curiosity, like, oh, I would like to see that, but like I would love also like, oh, which problem should we tackle first? I know like
Yeah.
composability and like interop is a huge problem, right? But with so
Definitely,
much
definitely.
ideas, maybe like, okay, what should I go first? Where is the big opportunity?
Yeah, so I mean, at least, from I don't have a particular take on this, like in terms of, particular use cases or problem sets to actually focus on. I think, the one that I mentioned that I had some context was about privacy.
True.
And these rollups don't necessarily have to be public, right? They can be private. I mean, and I think that's totally fair. And then validating that the chain is integral, and there's no tampering, right? So I think that could certainly be particular use cases if anyone has anything in mind on this front. This is extremely important for financial transactions, right? So particular where I am coming from this angle is like financial derivatives between banks. So yeah. So I mean, it's I think a big problem. It's a big market, right? Value wise. So yeah.
True. It's something we didn't brought to the database of ideas, but like privacy purpose related chains and like use cases privacy.
Definitely.
Yeah, and especially if we look right now how the Ethereum ecosystem is having this huge wave of like institutional onboarding.
Oh yeah.
I like it. I like this momentum. Gabriel, thank you so much for being here with us, for hosting the session. We're gonna make sure to make all the cuts in the playlist, so you can also bring even like broadcast more for other devs. I just think this helped a lot of them, even they already comment about this. Thanks a lot.
Awesome. Happy to help. All right. Thank you.
Thank
Awesome.
you.
Thanks. All right. Let's see here. So up next, we are going to have a presentation from Ida at Hyperlane. Let me bring her up on stage. She's going to give an intro to Open Intents Framework. Hello.
Hi, Ida.
Hey. Hey, guys.
Hope
Awesome.
you're doing good. Thanks for being here with us, supporting like from Hyperlane side. I think was one of the first supporters we had from, well, Open Intents. Okay, I want to be part of. I think it's a great public goods and initiative we're putting together with so much great players and ETH Foundation leading. Thanks for being here.
Yeah.
Yeah, for sure. Thanks for having me. I'm just recovering from a cold, so I apologize for my voice in advance. But hopefully I have some tea in case like I got stuck during. So we should be good today.
Feel free to stop for your tea.
All right. We have over 300 viewers right now, which is awesome. I'm going to pull up your screen now, and you can take it away. Maybe give a quick, maybe for those who don't know, TLDR on intro on Hyperlane and everything, which maybe you're already planning to do, but just a reminder. And then we will we'll get off the stage, and you can take it away.
Awesome. Thank you.
There it is. All right. You should see your screen now. All right. Take it away.
Bye-bye.
Okay, super. So hi, everyone. Today, I want to give an overview of the Open Intents Framework, which was recently launched. And as we mentioned before, it was an initiative led by the Ethereum Foundation, BootNode, and Hyperlane, and supported by the wider ecosystem. And yeah, today will be like a short overview. And after my workshop, BootNode will be continuing more deep dive into the framework itself as well. So before we even get to that, my name is Eda, and I'm a developer advocate at Hyperlane. To to give a quick intro to Hyperlane is that we are building a permissionless infrastructure for cross-chain messaging. Essentially, what this means is that we build the tools for different environments to talk to each other. And today I'm going to be talking about the Open Intents framework, which was an initiative which we participated in as well. And it's actually going to be my first time presenting it, so I hope it will go well. And don't worry if you don't know about intents, you probably heard about them, but it doesn't require any prior knowledge. So we're going to be covering everything from the ground level. So hopefully, even if you have some background knowledge, it will be some kind of good refresher. But even if you don't, that's completely okay. I'm gonna move over here to this slide. But yeah, as I mentioned, we're going to be talking about what are intents, why you should pay attention, and then give a quick introduction to the Open Intents framework. We'll be talking about the key components. I'm not going to dive deep into them because after this workshop, BootNode will be continuing and they'll be diving a bit more deeper. And then lastly, we'll kind of talk about looking ahead, like what's after intents, what this open building in the open and modular infrastructure enables. So we'll be talking about that. Okay, perfect. And yeah, as I mentioned, you probably heard about intents at some point. You probably read them on Twitter, but I feel like they've been a buzzword. So many people have heard of it, but not many people know of it. So I hope to cover them from ground level. I honestly have been hearing about them for the past, I guess, few years, but only until recently was the time, like 5-6 months ago, when I was more interested in how cross-chain bridging and messaging happens, is when I actually got into them. So no worries at all if you are hearing it for the first time or if you know of it before. And okay, so what are intents and why should you care? Before we even get to intents, I think it's important to just take a step back and see where we are today and how we got to where we are and why intents even matter. So if we look back on scaling Ethereum, like Ethereum started out as a great project. It was one chain. You could interact on its, on a single wallet, interact with a single chain. But then what happened that it became it was unable to handle the load. So it was very hard for even transactions to be processed. It would take ages. It would cost a lot of money to even send a single transaction. And then Vitalik introduced the Rollup-centric roadmap 5 years ago at this point. And so with that, what happened was that we saw the rise of all these different L2s, like Optimism, Arbitrum, ZK Sync, etc. So there was like a boost of innovation and so many different environments popped up, which actually made Ethereum scalable. So that was great. Like the Rollup-centric roadmap helped us to scale Ethereum. But at the same time, what this bought was, what this bought in the end was that it made Ethereum very fragmented. So when we look today, this is like a screenshot from L2 Beats. You can see there are many L2 environments like Arbitrum, Base, Optimism, Starknet, you name them. There are different environments. And even beyond Ethereum, there's also all these different L1 environments as well. So it was great progress that we went from, Ethereum being a single chain and then being too congested and then having introduced the Rollup-centric roadmap. That being successful, Ethereum finally being scalable, but then now Ethereum is fragmented. So now we have a new problem to kind of address is how do we solve this fragmentation problem? How do we make Ethereum feel like a single chain again? And today, when you want to transact on Ethereum, you kind of see all these blurry screens. You probably might, might not even be using these wallets, but you have your wallet of your choice, but you have all these different network settings, 7 networks connected to the single app. So it's definitely not easy, even as someone who's been in this ecosystem for quite a while. I wasn't here when Ethereum was usable as a single chain, but I have been here for quite a while, for the past 3 years. And it's not easy still to kind of, constantly change networks, be like, oh, okay, this transaction was on Ethereum. I actually need to change to Base mainnet, or I need to change here. I need to send my funds from here. So it's definitely not easy to transact on Ethereum today. And yeah, this is kind of the point we're at right now, is that we scaled Ethereum to a point, it's very fragmented. It's just does not feel like a single chain. And what we want to do with all these different initiatives is that the goal is to make Ethereum feel like a single chain again. So you want a single wallet, ideally, you want a single interface, you want to just transact, and you want to be able to send money from chain, from not even chain, but from person A to person B. So this would just make your life easier and be the Ethereum that you want, that scales and actually like is the financial layer of transactions or DeFi or any kind of financial instruments. And yeah, so given that the goal is to make Ethereum feel like a single chain again, there are many initiatives for this. There's different stuff that need to be happen, such as the account abstraction is one of them, and then there needs to be like some kind of wallets infrastructure that makes everything happen in a single wallet. But then there also needs to be very easy token bridging. So you want to easily send tokens from chain A to chain B. So like when we look here from like Optimism to like another to Polygon or to Scroll or to ZK Sync, you want to like easily send your assets from one chain to another. And this shouldn't feel like very hard where you go, where you bridge your assets, where it takes a long time. So yes, bridging solutions exist and they work. But the problem there is they're mostly like slow. And actually, yeah, I think I'm talking faster than my slides. But basically what we need fast and seamless interop to get to where we want, which is like to make Ethereum feel like a single chain again. And that's exactly where intents come in. So at the core, like intents kind of change the way the transactions work. And I kind of want to give an overview here is what I just when I explain how transactions actually work, is in the current infrastructure, when you look at token bridging or when you look at transacting between chains, is that what happens is that you need to figure out a way to get from point A to point B. And you have to specify every instruction on the way. So let's say you want to send tokens from chain A to chain B, from Optimism to Arbitrum. What happens is that you first deposit your funds. You wait for the funds to arrive. So you wait for the finality over there. And then once that funds arrive to the next, is then you can send the message. So you have to wait for that time. And that kind of introduces like an extra, how can I say, like an extra wait period, which most people don't really want to wait that long to make like a single transfer transaction. So this is kind of the problem with most of the cross-chain transactions today, is that, yeah, like they're a good way, you might not love like some of the different assumptions, but they basically kind of make you wait for the finality. And that's exactly where intents kind of shine. Is now instead of users manually defining, hey, like this is exactly the steps, now you have to wait for the funds to arrive here. Putting that aside, the new way which intents work is that intents allow you to declare what you want. So intent, you can say, hey, I want to send my funds from A to B, instead of saying, hey, like exactly this is the amount of funds, this is the call data, this is all the instructions you need, send it from here to here. Now what you say is that, hey, I just want to send my funds from A to B, and I'm going to rely on off-chain specialized actors called solvers to do this for me. So that's kind of how intents change and how the transactions are today, versus what kind of the innovation that intents produced. So for example, with intents is that I think this is like a kind of nice overview, is that you want to swap 100 USDC from base to Arbitrum. And instead of, as I mentioned, like specifying the exact instructions, the solver, you can think of the solver as like, there's like a marketplace of solvers. So you kind of broadcast the transaction, and then the solvers compete to kind of take that transaction, and which is the specialized off-chain agent. And they kind of take all the risk and the routing and settlement. So you don't have to worry about that wait time for that finality to arrive. So then you can send the next message. So this way, you kind of get like way fast interop. So you don't need to wait until the finality. You don't need to wait for all the processing. But now you can basically do it in under a few seconds. And yeah, hopefully this kind of gives you a small overview of intents. And yeah, I like this description here. It basically, the shift represents a move to a declarative model. So now the user can specify what they want instead of where they had to manually define how to execute every step. So yeah, so with the shift to intent, now you can basically say, hey, I want to like move 100 USDC from base to base, from base to Arbitrum. And I'm giving all this responsibility to the solver. I just want to do this. And when you look at most apps, that's actually, or users don't really care if like, hey, like this is the call data, this is like which path I want to take. Like the user just wants like 100 USDC instead of on base, they want it on Arbitrum. So yeah, that's basically how users define it. So this makes the life of every party involved a lot easier and offloads a lot of the responsibility. I've been saving my voice for this presentation, so hopefully it's going okay. But now I kind of want to talk about building intent-based apps. Okay, so intents seem cool, right? Like they seem like they solve a lot of the problems we have with, cross-chain messaging. But why haven't we gotten there if intents have already been a thing for the past few years? Why aren't we seeing like so many intent-based apps? Like, yeah, there are like a few. There are like intent-based protocols and apps and stuff like that, but it's still not widely adopted. Because, well, building intent-based apps is quite hard. When you want to build an intent-based application, and when you're a new chain, that creates quite a lot of problems for you. Well, not problem, but let's say roadblocks. Like you have to either partner with an existing intent protocol, so you have to reach out to them. This requires like custom integrations, technical research, BD negotiations to get your chain supported. And this might be quite hard if you're not like a larger chain. And then the second part is to build your own solver infrastructure, which also requires quite a lot of like extra technical work. And yeah, that's kind of the case when you want to build like an intent-based app today. Like if you're a big chain, you probably have a higher chance of partnering with an existing intent protocol like a cross. But if you're a small chain, this doesn't really like apply to you. So you need to find kind of like a new solution to be, okay, like I like this intent thing, but how can I actually put it to practice, right? Like I don't want it to just be like a high level concept which only some chains kind of use. And yeah, this is kind of the way like I like to describe the view on intents today, is that intents are here to solve quite a lot of the fragmentation issues with Ethereum, and they offer a fast and seamless interop. However, in the state of which we are today, buildings with intents are hard. And well, if we have to be honest with each other, if intents are going to scale, we do need like common standards and an open and modular framework. We can't just be like, okay, like only big chains can do this, or only like, only you can do this with certain BD negotiations or something like that. That's not like a scalable way to move forward. And that is exactly where the open intents framework comes in. So I think it's also worth mentioning, even before moving to the open intent frameworks, there have been like quite a few like nice standards, like the ERC 7683, which was developed by Across and Uniswap, which is the ERC, which defines how the intents order should be made. So it kind of defines the transaction of what you need to add to make an intent transaction. So there are like common standards, but there is one thing to like define a standard, but also to build like a framework around it, which makes it easier to adopt. Because there's, I don't want to dismiss the efforts that have been gone before building the open intent framework. So I think it's worth mentioning that there have been like such ERCs and work put in to do that. So given that, now I kind of want to introduce the open intents framework. Okay, so enter open intents framework. The open intents framework, and yeah, you might have seen this image on Twitter or on one of the blogs you read recently, but it was recently launched, and it's led by the Ethereum Foundation, Hyperlane, and BootNode, and supported by many ecosystems and projects in the Ethereum ecosystem. And basically, yeah, as you can see, intents for everyone, with everyone. So it's a collaborative effort. And the goal is to build like an open and modular framework to making building intent-based applications easier. Yeah, so as I mentioned, the open intents framework is an open source and modular framework. And the goal is to build and deploy intent-based applications easy. Now, what we saw and with the need to build open intents framework is that, when you want to build your own intent-based application, most people had to like kind of build a lot of the infrastructure from start. And they kind of, there was a lot of teams building their own infrastructure. But when you look at it, building the same thing, it kind of makes sense to like have certain modular building blocks that people can use instead of having to start from zero all the time. So yeah, of course, it's important to customize. So I'm not saying like these are like, hey, like building blocks, which you cannot edit, but they're very customizable building blocks, which you can customize according to your needs. So this way, instead of every project building their own kind of infrastructure, they can tap into these to these pre-built tools and customize it according to their needs. And that's kind of the goal of the Open Intents framework. And as I mentioned, it's created as a public good, led by contributors from Ethereum Foundation, Hyperlane, BootNode, and with support from the wider Ethereum ecosystem. This was a cool tweet. This was quite a cool tweet, which I saw quite recently. Someone posted that they had the chance to test the Open Intents framework and that it took less than 5 seconds to bridge 10 USDC from Base to Arbitrum. It's a huge step towards a multi-chain future and making Ethereum feel like a single network. So yeah, I thought this was like a really cool representation. I might have used the exact same words, so it was not my words, and I love to put this here because I think it really represents what I also think. But yeah, as the whole goal is to make like Ethereum feel like a single network again, I think that the Open Intents framework are really a big step in getting there. So I do want to talk about the key components. I'm not going to dive deep here. I know I'm also almost on time, but because also like BootNode will be covering it in depth just right after me. But I just kind of want to mention to make it a bit more concrete in your heads, because I mentioned like, you know, Open Intents framework is like, okay, this framework which has pre-built components, but what exactly are there? Like, is there actually like some code which I can take for me to use? And the answer is yes. So with the Open Intents framework, what we try to do is that, okay, instead of giving you just the standard, let's give you like some kind of code, like some kind of written framework, which you can directly take, kind of customize, you know, add your logo, add your own customization settings and all that, and go ahead and start using it. So basically what the framework has is it's made of 3 different key components. And the first is the composable smart contracts. It uses a base 7683, which is the ERC developed by Uniswap and Across as a base contract, which can be extended. It has the second component is the open source solver implementation. And the third component is the UI template, which is very customizable, which you can kind of take and directly start using. Because the UI work does introduce quite a lot of extra work. So all these 3 building blocks are available to you, and they're all customizable. They're all like base building blocks, which you can add onto. And as I mentioned, BootNode will cover this section in detail. So I'm going to be leaving the rest of the explanation to them, which will be right after me. And the how to start building section, this is again up next with BootNode. So looking ahead, so I'm almost coming to the end here, but basically I just want to give a shout out to all the work which has been doing to scale intents with open and modular infrastructure. So the Open Intents framework is part of like a larger effort of all these different teams working together. So basically all the goal here is to make Ethereum feel like a single chain again. And with standards like the ERC 7683, the solver coordination efforts by Khurana and Uniswap's The Combat, and other like liquidity solutions, better user interfaces, reference solving is, kind of efforts towards making Ethereum, again, toward not just Ethereum, but basically the goal here is to make intents more widespread and easy to use. And there are like quite a few efforts. Hopefully the Open Intent framework will be a good starting point for most people building intent-based applications. You can scan the QR codes or go to the website openintents.xyz to find the details and to read more about it. You can directly start building with intents. Hopefully this was like a nice and short overview. I think my voice just lasted enough to make the presentation. And if you have any questions, happy to answer them. I highly suggest to head over to the openintents.xyz website to kind of check out what we have over there. And yeah, this was kind of my presentation. Again, happy to answer any questions that may come up.
Hey, thank you so much. I just popped a little question that we did have. And I know that you did obviously reference 7683, but someone was asking for maybe a little bit more, maybe clarity on the difference between using the, OIF and the ERC.
Yeah, for sure. And that's a great question. So basically, the OIF does use the base 7683 contract. And the difference here is that the ERC specifies a common standard to make intent orders. But the difference between the OIF is that the OIF provides the other components as well. So that it doesn't only specify the common standard to create an intent, but basically it gives you also the solver implementation and the UI. So then it gives you like some other piece of code which you can directly start building the application instead of saying, hey, like this is the standard and you can start using it. That's kind of the way I like to explain it. Hopefully that kind of provides the answer.
Yeah, absolutely. And if you have, if your voice can last, one other question that I'll pop up there. Are there any cons of intents in terms of security?
Yeah, I think my voice can ask one more question. Okay. Yeah, for sure. So the cons of intents in terms of security. So the thing with Open Intents Framework is that you can basically specify your security constraints as well. So you can say like, hey, I want to use this for security. I want to add custom security implementations. Is that it uses kind of like a modular security infrastructure. The base implementation uses a Hyperlane ISM, which is the Hyperlane intersecurity model. But you basically have the option to customize it according to your needs. So again, it's really up to you to add like the security which you require. And I think that's pretty cool because it kind of gives it to the developer to specify what kind of requirements they want.
Awesome. All right.
That's great. It was a very nice session explaining things like the motivation behind from even like the components and things to be considering when looking the open intents. Thank you so much for the session. I hope your voice gets better. And I think we can continue the session with a part 2 that is with Lisandro from BootNode. Maybe you want to bring him on the stage with?
Yes. Bringing him up on stage right now.
Oh, Fernando as well. So Lisandro and Fernando.
Cool. Let's see.
Again, thanks so much. And also to organizing this split of sections with BootNode and Hyperlane. I think it's going to be an amazing split up. And Fernando and Lisandro, thanks for being here with us.
Hey, thank you for having us.
Yeah, so we're going to dive into building with OIF a little bit more here. So we're looking forward to that. Got a pretty good audience watching, according to the numbers that the platform's spitting at me. So yeah, should be good. I'll let you. I mean, unless Mariana, you have anything else you want to say? Should we just let them take it away?
No, you guys can take away. I'm super curious to know how I can start building with open intents. So excited to see it.
Absolutely. And then, yeah, just quickly, I know that BootNode is obviously was involved in OIF, and it's end-to-end engineering partner for dApps, protocols and networks, and yeah, core builder of OIF along with Hyperlane. So, all right, we'll let you guys take it away. Thanks so much.
Thank you.
Okay, thank you. Well, yes, Fernando and Lisandro. I'm Lisandro, and together with Fernando, we'll trying to give a walk through the Open Intent Framework repository and what's in it. So let me start by introducing BootNode and ourselves. So at BootNode, we are a team of Web3 builders partnered with the innovators to bring open, decentralized, and permissionless solution. We not only deliver just tech, we stand by our partners on every step of the way by offering full support across strategy, execution, and so. Since 2017, the team has scaled major projects in the ecosystem, including Maker, Gnosis, Aave, Synthetics, Eigenlayer, Drive, Gelato, Hyperlane, and many more. Well, Fernando is a full stack developer at BootNode. He started working on 2014 and moved to the Web3 space on 2017. Myself, Lisandro, I'm also a developer at BootNode. I'm more on the Solidity side, and I've been working as developer since 2006 almost, and I'm in the space since 2018. So let me see. Okay, regarding the repo, you can find it under the BootNode organization GitHub with the name of Intents Framework. And you will see that there is a Yarn monorepo with 2 workspaces, the Solidity one and the TypeScript one. In the Solidity workspace, of course, you will find the smart contract that we developed and that I mentioned before. And in the TypeScript workspace, you will find 2 different projects. The solver one that contains some abstraction that should be useful for any new solver implementation, and also 2 reference implementation that we develop using those abstractions for filling intents for our Hyperlane 7683 contract, and also echo intents. Then the other one is the UI that contains the app that is being used in the demo and is live, which is based on Hyperlane warp route UI template with some little tweaks to create intents instead of sending the token through warp routes. Okay, so talking about the smart contracts, in the Solidity workspace, you will find a Foundry project with a little tail that instead of using the Gitson module for dependency, it uses a Node module. So if you're going to use or hack some code there, have that in mind. And it basically contains 3 contracts that we try to build in some sort of layer, right? The first one, and probably the most important one, is the base 7683, which was mentioned by Eda previously, that implements the interfaces defined in the ERC 7683. And we try to make that contract in a way that will allow supporting different types of order, right? Not just one. Then on top of that base 7683, you have the basic swap 7683 that extend the base contract with logic specifically for a specific order type that we wanted to use or to have like a reference, right? And this order type will allow to swap an input token on one chain for an output token on the destination chain. Then on top of that basic swap contract, there is another one, which is the Hyperlane 7683, which extend the basic swap by integrating Hyperlane as the messaging layer for providing proof that are required for settling and refunding. And well, and apart from those contracts on the Solidity workspace, you'll also find some scripts for deploying the contracts, and also some others for opening orders on the Hyperlane 7683. Well, in the README, you can find instruction for using those scripts, but it basically requires setting some environment variables and running some script using Yarn. Okay, so both the basic swap 7683 and the Hyperlane 7683 are, as we said, reference implementation, right? So if someone wants to implement a different order type, like for example, an order type for, instead of swapping one token in the origin chain for another token on the destination chain, let's say swapping multiple tokens, or probably executing arbitrary messages on the destination chains, then you can replace the basic swap 7683 by your own one. Or let's say you wanted to use a different type of proof. Instead of using the Hyperlane messages, you can replace the Hyperlane 7683 with your own logic, right? If you want an example of this, there is an open pull request from the people from Polymer, which is using the event proof from Polymer instead of the Hyperlane messages. And I think it's the turn of Fernando.
Okay. Hello. Well, I have to give an explanation about the TypeScript part. As Lisandro said, there are two major packages there. You have the UI, which is a fork from, it's based on the Hyperlane web routes UI. And it's, as you can see there, it's a focused on intents, so it has quite some modifications that makes it suitable for intents. And to do so, we have to make this was like a quick period of development. So there we have to patch some dependencies like the SDK from Hyperlane. So if you go there, you will see like a lot of not probably you can see the patches there that give the result on the application, functional application that you will be able to test. But anyways, we have been working with Hyperlane to make this more standard and functional. So there are two major PRs open, one for the SDK and the other one for the WebRoute UI, to fully integrate in these standard intents into their UI. But anyways, right now, if you go to the domain that Eda shared, you will be able to see and test the application. One particular thing for you to test it, I don't know, Lisandro, if you can give me the if I can present for a second.
Shall I change?
No, give me a moment. Okay, I will. No, if you can. Okay, sorry. If you can open the WebRoute TS file there, that's a link. If you can, if you not, I can walk people through it later. But if you're not able to share it, don't worry.
No.
Okay, on that file you will be able to set up your routes. This is like a for the demo. What you have, it's a set of tokens that have some configuration for an origin chain and a destination chain, and you can set there two other things aside from the list of tokens and chains that you will be supporting. You can add like a cap to do a maximum transfer depending on the token that you are using, and the other one, it's like the fee that you like to. This is a hard coded fee that you will be able to set up for depending on the destination chain and the origin chain, the route that you define. So the fee will be fee that the solver will get from this from this operation. So basically, okay, the UI is that it's an adaptation, something easy for demonstrate how the framework functions. And if you can move to the other slide, and we can get a deeper view on what's the solver. Well, this, I think that it's the core part of the TypeScript side. It's an old TypeScript application, and what you have here, it's like, yeah, it's you have the solver has two main key components that it's split into the indexer and the filler. So the indexer, in our case, in this case in particular, is they're responsible for receiving the information for the intent being generated, this order that Lisandro has been talking about. And the filler will be the counterpart that will take that order and process it and fulfill the intent. So what we do is a modular implementation. In this case, our current implementation, the one that you will be able to work with, has a base class that it's named base listener, which is just a service that listens to events on a set of chains that you define, process that information and sends it to the filler. And the filler has a set of basic steps. One, it's like, the first one is to verify that that the transaction is suitable for the solver. That will be going through a list of checks that is for allow and block list that you can define. Then a set of rules that will be run against this every order that arrives, and you can create your own rules there for you to decide whether it's a suitable or not order to be filled for the solver. And the last steps will be filling actually the order on the destination chain. And lately, the last one will be the settlement, which is withdrawing the funds on the origin. No, so the flow, it's a user sends some tokens on the origin chain. It will be logged on a contract. The solver application will listen and realize that there is a new order. Will fulfill it if it matches all the requirements, and then we'll do the recovery of the funds on the origin. We have videos on. I can show. Now see. Yes, let me see if I can share my screen, and I will show you. Give me a second.
Let me try and stop my screen share.
Yeah, but yeah, go ahead.
Okay, done.
Okay, I will share.
Hey guys, you try to, if you share, I can make it go live up on stage.
No, okay, there it is. Sorry. Let me see if you are able to see it.
Yep, there it is.
Okay, so
cool.
First of all, this is the base application that we use, the DApp that we have used, and here is our adaptation. As I said, it's an easy to adapt and modify. So we did this in less than a day. The changes. The design is not on me, fortunately. We have somebody that has a good eye on the design, and people that know how to adapt them. But it was like a day work. Anyways, continuing with the flow, you'll see here I can define an origin chain, a destination chain. This is live now. you can test it. These are main nets. So this is from Marathon to base. I will set one USDC sent to myself. I click on continue. This is run through the Hyperlane SDK, do some checks to verify if the amount is valid and everything on the user side of the equation. You sign it and you send the order. This was the action of sending the order. Now the solver is listening the event. It has already done it. So it did all the checks and did the transfer, no? And I have the funds already on the destination chain. So you can see here the transaction hash on the destination chain where I received this one USDC. And you can see something that I missed to showcase, but on this contract interaction, on the origin chain, you'll see that I sent 1.05, that this 05 is a hard-coded value for the fee for the solver. So this 1.05 is what the solver will be getting on the origin chain as a as the fee for the operation. And I can, as I said today, if I have a little bit of time, I can show the configuration files for the UI. Here is where you set a top values. This once again is like it's what's a quick development, but it's like quite a standard in the industry. It's like the top max that you the zero address will be the Ethereum address and the Ethereum token. I mean, and ITT it's a test token, but it says here it is saying that a maximum of 100 of ITT, and here is a maximum of 0.01 ETH to be sent. So if you go to the UI and hit max, it will be capped that. In this case, it is set to 50. That's why I have no problem there. But and the other case is here you have the list of tokens where you will see this is in the code, but you will see how the mapping between a token and the different destinations are being built. Obviously, you can reach me out for any details on how to do this or how to tweak it. And finally, this is the definition of fees. But once again, it's a bit convoluted, but once you get time to read it, it's quite easy. If you happen to have to work with any chain that it's not being listed or supported by the SDK, the Hyperlane SDK, you can manually add it here with all the information. This is all warp-wrapped UIs, so you have a lot of documentation there. On the solver part of the equation, you can see here we have the two implementations that Lisandro talked about, the Eco one and the Hyperlane one. The base, here you have the base filler and the base listener. Both of these implementation extend from that and make their own definitions of the business that they are working on with. And each one has a basic structure. And this structure is quite helpful for you to, you can see what we have already done and based on that create your own set of rules and do whatever you need based on the business that you are running on. For instance, one last thing that we did was to create, there. One last thing is to create a script to facilitate this creation of a solver. So you can run this script, and it will create a boilerplate for you to let's say my solver. Obviously, this will be a name. It asks you if you want to enable it by default, and there it is. There you have your my solver with all the basic files and configurations from where you can start tweaking and making your own solutions. This what it does is modify a couple of files to make it the application aware of your newly created solution. And I think that will be all on my side. You can also remove it by just calling the script, checking your solver and telling it to remove it, and there it is. So I will stop sharing my screen if I can. Okay. And I think that will be all. I don't know, Lisandro, if you want to add something else.
No.
Okay.
I'm done.
All right.
So,
thanks so much, guys. Any questions from the audience? Happy to answer any. I don't see any right now in the chat, but
so anyway, if anybody has any question, obviously probably sorry, I was a bit nervous, but if there's any further or needs for anything, that you can reach us anytime. We'll be there.
Yeah, you can reach us.
Amazing. We have office hours from BootNode, right? And it's starting this Friday, correct?
Yes.
So you want to just share with everyone here what time is the office hours from BootNode, so anyone that is going down the route of open intents can just like have a session with you guys to solve it or even to discuss. Thanks.
Awesome.
Do you want to share the time of
no,
I think that Lisandro was about to.
No, I actually don't know the time. I know that there is an open.
There you have it.
Here we go. Margaret's got it.
Okay.
Ooh.
Awesome. Thanks, Margaret.
Yes, that's on spot. Thanks, Margaret. No, that's amazing.
Yeah.
And guys, before we finish here, what would you say like would be the most important things and pieces to look when building with these contracts or this tooling? Something that maybe sometimes people they just misstep or doesn't look, they didn't go look like properly down the line and they just miss it and have to realize, oh, this was important, or like something they can miss it when building it.
Yeah, good question. Probably, in my opinion, probably it would be, trying to make it the most generic as possible was the hardest, and there is much to do on that side. So it is useful for anyone to use it, right?
Okay. Yeah. Following that reasoning, yeah, I just want to stress here that we started this as a demonstration for this set of contracts and the standard 7683, and it grew like a lot, and we started from a proof of concept and we are moving to something more. Not only a reference implementation, but some implementation that is functional and easy and ready to be used. For instance, what we have in our roadmap is the not only being based the origin of the information on these events, blockchain events, but also any other kind of sources like WebSockets, HTTP post, subgraphs, or whatever the other origins are. So the idea is to continue scaling and to make it, as Lisandro said, the most modular possible and easy to tweak and adapt to any need. That's the hardest part of it. But we iterate constantly based on our needs too. No.
Mm-hmm. Yeah, and also considering that this is this is open, right? As the name said, we would really appreciate any type of collaboration, suggestion, pull request, anything that the community can collaborate with. It will be really appreciated.
And which kind of cool projects or applications do you see or you envision or you'd like to see being building with the existing repo and toolings we have? Maybe we start with you, Lisandro.
I don't know how I mean, we are really focused on moving forward with this and improving it. So I haven't had the chance to think about what I would like to see or who I would like to see using it. I mean, but don't know how to say what to say. Sorry.
I don't know if Fernando has anything to complement. If not, we can just go for next speaker. Fernando, if you want to say like some last words for the builders and the hackers, feel free for both of you. If not, we can just bring with OpenZeppelin here with us.
Yeah, they're not in the studio yet, so we need to either delay. I mean, technically scheduled is we're actually ahead of time, which is so rare. But it's 13 minutes until the next one is supposed to start. But I pinged them, and hopefully they are on the way. Oh, Francisco, is that? I think that might be him. All right. Well, yes. Thank you so much, guys. Yeah. Once more, BootNode is doing office hours on Tuesday, Wednesday, Friday at 10 a.m. So on the Discord. So sorry, that's our Discord or your Discord?
Our Discord.
Our Discord.
We have a section for anyone that is building with us for the hackathon. For who is building with us in the hackathon. Some of them already in the Discord. If not, please come, join, get a verified role with us. We have a stage just for office hours. So Espresso is going to be there, BootNode's going to be there, Cross is going to be there. So you will be able to talk with all these developers to just help you if you have any problems or doubts. And if you're also in this session and you're curious in what is Build and Brew about, is our first global hackathon here in Espresso, where we're incentivizing builders and hackers to deploy and learn how Espresso works under the hood. We're incentivizing everyone to deploy Arbitron Nitro rollups integrated with Espresso. And then going beyond this, in a separate pool prize and a separate track, we have cracking composability. There is where we have this focus open intents pool, but also we have just a core pool for anyone that builds cross-chain applications that are innovative and they're reading from Espresso confirmations. So if anyone is super curious and would like to join us, the registration is still open, Discord is open, and we are here to support in the journey. There's still more like 20 days to the end of the hackathon. So until the 31st March, everyone can enter and submit their projects.
Awesome. All right. Thank you so much, guys. I'm going to take you off stage.
Thank you so much, guys.
All right. Let's see. So I am wondering. Yeah, how about let's get Jean up here for a little bit. I think Francisco from OpenZeppelin needs a little bit more time. If anyone does have questions for Jean about any of the guides that he's worked on, now is a great opportunity. You can post chat if you're watching on YouTube. Unfortunately, I mean, I guess I could go to the Twitter stream, but unfortunately, the StreamYard does not support live chat engagement via their platform. Let's see.
Yeah. there's something I'd like to mention as well, because we were discussing about it when you asked the questions about the calf node itself. I just wanted to give a little reminder that like deploying your calf node is necessary for the second part of the guide. So mostly this workshop today was to give you some tools to go against the cracking composability track, but that you should be still eligible for the pool prizes if you just follow the first guide from Monday, which is just basically deploying your old rollup and everything. The idea for this is that we kind of came with the first guide, which is kind of available for anyone. The guide has been made detailed enough for kind of everyone to get a try at it and deploy your very own rollup. You do not need that much knowledge and everything. We're also setting up some office hours to answer all of the questions that you may have. It's, I think, a good and easy entry to trying out the Espresso architecture and building, well, just deploying your very own rollup very easily, because everything is made accessible. It was made accessible to you. So yeah, I just wanted to point that out, to tell that anybody is welcome to participate and yeah, give it a try.
Yeah, and also would like to bring a separate topic here. Someone made me a question this week that is you need to write on our Discord and our socials. And the question was like, how can I get the most of this hackathon in terms of prize? And so I was super reward driven this question. And I was like, okay, what would I do, right? If I want to maximize my chance of prize. So not saying that you're gonna get it, but first track, we have caffeinated code. Caffeinated code is about deploying your rollups, right? You can deploy 2 rollups per the 2 pool price. So you can deploy 2 testnet rollups and you can deploy 2 mainnet rollups. Of course, you still need to have make sure to send to us the IP server of your cloud. You need to send to us like the transaction hash of your create rollup function. So we are going to still go down the route of understanding if your rollup is eligible for. Then I will do this, 2 rollups testnet, 2 rollups mainnet. Then when I go to the most creative rollup idea, then this I can give you much tips. This is the judging criteria that we're going to be analyzing, but I will definitely submit like example, Infura got us a good point here with privacy. So why not about like a privacy rollup? But you go down, you do your homework, you do a little bit more of research. I think it's a great idea. I will definitely incentivize people to look into it. And then when you go to the second track, you know, you're maximizing your efforts. You think about cross-chain applications. And then we have this whole database of ideas. You can go beyond, you can have other ideas as well. You can see like starting with the problem. What is the market missing right now? We know Ethereum is lacking composability. We're talking about the fragmentation. So which kind of applications or toolings or like under the hood, what we can have to solve this. And that's why we have this special pool prize for open intents. That is like this engine that will make way better UX for all the Ethereum ecosystem apps, rollups, users, everything. So this is how I would approach it. If you want to even go beyond, you want to do something with open intents and still make an application level that is using this open intents tooling that you build, I think you're maximizing a lot of your chances. But yeah, this is how I would approach this. I'm gonna do a write-up on this as well. If anyone has any questions, I know a lot of people ask about the eligibility, like and if, how you're preventing CBU attacks and etc. We are just asking social accounts. We will look into like new GitHub accounts. We will try to make it the most human possible to be judged and to be evaluated. We don't. We're not encouraging anyone to write any scripts to crack this hackathon. We do want everyone to leave this hackathon learning about rollup development, learning about like how Espresso works with rollups, and even learning how much we can improve with these new cross-chain apps, reading from Espresso, or even the Infura protocols that we have here as partners.
Cool. because we are so ahead of schedule, Francisco from OpenZeppelin still needs a little bit more time. So, but I brought up Kanishk. How do you pronounce your name? Is it Kanishk? Oh, you're muted. You're muted.
Thank you so much. Yes, that is spot on. That's Kanishk.
Awesome. So we have about 5 minutes until OpenZeppelin's scheduled to begin. But Kanishk, he's from Across Protocol. He's going to show us some intents in production. Do you need me to share? Do you need to share your screen and I can put it up there?
Absolutely. So let me get started right here. I hope you can still hear me correctly.
Perfect. Yeah, I can hear you fine.
Awesome. So throughout this presentation, we've been talking a lot about open intents. And it is with a lot of pride that I present that Open Intents framework has been built on top of ERC 7683, which is something that Across and Uniswap co-authored, and which is also something that we have, well, a part of it in production right now. What I have here is a documentation page that I created along with our amazing engineering team, which just walks a person through what the mental model for intents should be. And it is also something that I'll touch base later on. So if in case you as a viewer don't catch up completely, don't worry, we'll cover it in detail. But the mental model that you must have is that intent is just like filling an order ticket. What is the deadline? By how much time do you want this particular transaction to be completed? What is the amount of money that you want to send? And from which chain to which chain do you want to go? It is literally that simple. And just look at it like you're filling blanks in a ticket that you want to then submit to a relayer, which will take this particular ticket from you and do the transaction for you and give you the money on the chain that you want, right? So in this particular scenario, we have two chains supported. First is Base, the other one is Arbitrum. And all that happens here is that you take the intent generator website that I created some time ago, just put in your wallet address and put in the amount that you want. And in this particular scenario, we go from Base to Arbitrum, and that's it. Very simply, I'll also open the intent generator website so that I can just walk people through the example. I will take my wallet from MetaMask. I hope I remember my password because it will ask. It didn't ask. Great. God bless MetaMask. And then we have, like $10, and you just generate your intent through this. What this will do, it will take $10 from Base to Arbitrum for you within 30 minutes period. That is your fill deadline. And once you walk through all of this, essentially what will happen is that you will be able to go through the production contracts that we have. This is also another way to just generate intent. You'll be able to go through the production contract that we have and see intents in production and execute all of this your own self. So if I can just show you, I won't execute it right now because we may just run over the time, but I'll just show you the contract and how you as a user or you as somebody who is an enthusiast in the intent framework just wants to walk through it, can do it. Here is the contract that I've been speaking of, and you can obviously find this in our documentation. You go to the contract itself, you go to write the contract, and in this particular scenario, please make sure that your wallet is connected to Basecamp, and then just go to open and fill in the intent. As I mentioned, the mental model is being repeated here. You have the fill deadline, which we saw in the intent generator. You have the data order type, which is just a bytes 32 format, which we'll talk about later in my presentation. And finally, just the order data, which contains a lot of variables around the recipient of the funds, the from chain, the destination chain. From chain is the origin chain, the amount, and other details around gas. And then you just write this transaction and it goes from Base to Arbitrum intentfully. So if you're a hacker that's watching it and you want to implement this, we'd love to support you. A lot of teams have supported ERC 7683 by now. I think the count is above 50. We also want to thank Espresso for having us here and talk and yap about intents all throughout the hackathon. So yeah, we're super happy to present,
That's
super happy
great.
to support.
That's
and
amazing.
yeah, it's all in production.
Please send us
Absolutely.
the link. Send us the link. I think we do need to play around with these tools as well.
Absolutely. But yeah, here you go. So yeah, that is all I had to present to just fill in the time. But we'll talk about this more when I'm on stage because I do have a lot of code to share as well. But yeah, that's about it. And I'm gonna now
I'm
hand it
excited
back
for
to you.
this. Thank you, Kani, for coming on the stage and
Yeah.
yapping with us.
Awesome. Oops, that's right, John. Let's see.
So now let's bring Francisco on the stage. Hey, Francisco.
Hi guys, how are you doing?
Doing
Doing
great.
well.
Awesome.
Thanks for
Thank you for having me.
yeah,
Of
thank you for
course.
being here.
So I just shared my screen. If you can add it, yeah. Thank you.
Yeah. So now we're going to be talking about designing cross-chain primitives, and we're very welcome you to be here with us and explain to us more about it. Thank you.
Yeah, from OpenZeppelin. So if you want to also give a quick, intro, but then yeah, we'll let you take it away. Thanks so much.
All right. So yeah, my name is Francisco. I am currently a technical advisor for OpenZeppelin. I was the leading the development of the open source libraries, including OpenZeppelin contracts, the wizard, upgrades tooling, and a bunch of other things at OpenZeppelin. And now I am helping along with a few projects, among them everything related to cross-chain communication, interop in Ethereum and beyond. So what I thought I would do today is give an overview of what these systems are doing and what makes them complex. The reason why I want to do this is that, I was a smart contract developer for many years, and I'm sure many of you are as well. And when you develop smart contracts, you are in a very simple environment, quite a simple environment, where you can write your smart contract, you can call functions in the same environment on other contracts, you can read values, you can read balances, send tokens, do a bunch of stuff. If there's something you don't like, you can revert and undo everything. So it's an environment with really nice properties to program, and it can be quite simple. But when you start doing cross-chain things, the true nature of these systems, of these blockchains, starts to leak, and starts to really show and make things more complex. And when you begin to see these protocols and how you use them and what properties they have, you may not really know where they come from. And so I think it can be useful to get a little overview of that to navigate this space. So first, I want to review how does one, as a user of the chain, get to know the state of the chain. And so we have a couple of options. We can run a full node to follow every block. That's what we see above. We can follow every block. We can validate the consensus rules, and then we can go through each transaction and execute every transaction and reconstruct the state. And in that way, we can get a copy of the state on our computer and read from it, and we can get every balance, every piece of state, every event from there quite easily. But we might not want to do that, so we have a range of other options and things that we can do. We can run a light client where we validate the consensus of the chain, but we're not really re-executing everything. We're to some degree trusting the consensus to tell us what the state is, and then we can access it from there. Or we can just say, consult with a trusted RPC. We can just hit Infura and trust them to tell us what the state of the chain is. So what we're going to have in a cross-chain system is two chains where, not too dissimilar to what we have here with a user reading from the chain, we actually want another chain and possibly a smart contract on this other chain to get to know the state of chain A in this case, and read from it and interact with it. And so we have to ask exactly how is it going to do that. And we actually have a range of options that is similar to what we as users can do. We're going to be able to run something like full nodes or something like light clients or something like trusted RPCs. So we're going to look at that now. First of all, there's this is going to be able to happen in two different ways. In one way, the chains themselves are going to sort of provide this cross-chain link by default. is what I try to symbolize here. Each block of the chain is going to have a view into some other chain where you're going to be able to read states, and that's going to be provided by the chain itself. And in other cases, you're going to be able to do that with a smart contract inside of the execution environment of the chain. You're going to be able to get a view of some other chain. But actually, this diagram that we see here and that we saw above is really hiding the complexity, and it's too simple so as to be not really accurate. And the reason why it's not accurate is due to some kind of fundamental problem of cross-chain communication. And that is the possibility of reorgs. So what can happen when we have a simple link here from like the latest block to the latest block of the other chain is that while we might produce a new block and read this latest block of the chain, this block might be susceptible to being reorged. And what can happen is chain A in this case, ended up going on a different direction, producing different blocks that do not include the one that we read in the latest block in chain B here. And what this can mean is that we might have seen a transaction and thought that it went through, but actually in the real tip of the chain, it ended up being reverted. And this is a safety violation that is going to be key to avoid. So we can solve for this in two different ways. One is if the chain A here has some notion of finality, we're going to use that. And what that means is there's going to be some block in the past that is guaranteed that it will no longer be reorged. And so instead of reading from the latest, from the tip of the chain, our most recent block on chain B is going to read from an older block that is represented here by this green state that we know is not going to be reorged. So this will depend on the chain. For example, on Ethereum, the time to finality is about 15 minutes. And so we're going to be reading a block that is 15 minutes old. In other chains, it's going to be instant. In other chains, it's actually, there is no real finality. It's going to be probabilistic, most notably Bitcoin. And so we're going to have to wait up until some threshold where we are pretty sure, although it's not guaranteed, that the block is not going to be finalized. And in the case of Bitcoin, for example, it's going to be 60 minutes. So this is one of those things that I think some of you may have seen, like you transfer assets from one chain to another, and it takes 15 minutes. You're not sure why. This is the reason. And the other way that you can solve for this is to make the two chains reorg together. So in this case, when the chain above reorgs, the chain below is also going to reorg. So like from the start, you're going to have to make a commitment to reorg together. This also solves the problem. And you don't have to read an old state, an old block here to be safe. So we've seen quite a few options now of how to develop these systems. They can be built into the chain, or they can be based on smart contracts. You can wait for the finality of the remote chain, or you can commit to reorg together with it. And then you can have different degrees of security or trust assumptions, such as embedding a full node, or a validating bridge, which is similar, or a light node, or some trusted third party. And the right combination of these things is going to depend on the nature of the blockchains that you're connecting. So if you're connecting layer 1 to a separate layer 1, like say you're connecting Ethereum and some Cosmos chain, you are probably going to want to wait for finality, because these are different chains with different rules, different validator sets, and sort of different cultures even. And so committing to reorg together is going to be really hard. It's also, for similar reasons, probably going to be smart contract based. And because embedding a full node as a smart contract into the chain is not really viable because it's a constrained execution environment, you're probably going to be placing some degree of trust into third parties or a set of third parties or a separate protocol that is dedicated to this. In the case of layer 2s, you can do a bit better than this because, say, for reading the L1 state from a layer 2, by construction, the layer 2 node is going to have a full node of the layer 1. So it's kind of right there, very handy. You can take it immediately. It's going to be the embedded node kind. And it's probably going to be built in. You don't need to make it as a smart contract, and you're not going to be able. You're not going to need to wait for finality, because again, by construction, these two chains are going to be reorging together. For reading the L2 state from the layer 1, you again have a similar, similar situation in terms of reorgs. These chains are going to be reorging together. But it's not going to be built in. The rollup layer 2 is an application, so you're going to make it as a smart contract on top. And it's going to be the validating bridge kind, which is similar to the embedded node. You're kind of having a full node inside of the layer 1, but you do it in a way that the constrained environment is not an issue. So you would do fault proofs, or you would do zero knowledge proofs. And in the case of an L2 reading from another L2, you have the advantage that you are on the same sort of umbrella. So you, again, are going to reorg together, but the actual mechanism is going to be a little bit more complicated. So I'm not going to go into in depth here. So let's assume now we have solved this. As we've seen, it's not trivial at all. There are many choices to make and nuances and security things to analyze. But we can assume that we've solved that. What we get is some mechanism to authenticate remote chain state. So we are able to kind of construct this link that we were drawing up there. But this is not really what we want for the end developer, right? So we want to know now, how do we get from there to developer-friendly APIs, right? We want something that looks more like this, where within the same chain, we can call functions very easily, get results. We want to approximate that within the constraints of the finality risk and everything that we discussed above, but we want it to be developer-friendly. So I want to discuss now how we get from a mechanism for remote chain state authentication into a potentially developer-friendly API. So what does the authentication of remote chain state primitive give you? It can be a number of things. The rawest thing that it might give you is the block headers of the remote chain. And this does contain all of the information that you want. Like, using this, you can prove that anything happened on the other chain, or that the state is in a certain way. But it's going to be really cumbersome to use, because you're going to have to provide some sort of Merkle proof, and it's going to be a complex process. So it's not the developer-friendly thing that we're looking for. You might have state roots, but you're gonna of the remote chain, right? But you're gonna get a similar problem there. It's not gonna be developer-friendly. You're gonna have to provide Merkle proofs again of the state that you want. And additionally, you have another problem, which is that using state roots, you can, for example, prove that some token on the remote chain has a certain balance, like that some account, some user has some balance of a token on the other chain. You can, in theory, do that, but it's difficult to make that into a general purpose primitive. That is because it depends on the storage layout of the contract. This is not something that is standard. You don't know exactly in what storage slot of the contract you're going to find a certain balance. So it doesn't make for a friendly and secure and reliable and general purpose primitive on its own either. The next thing that's a little bit more useful is the logs, that is, the events that the contracts emitted. And this is It's a little bit better. It doesn't have the problem of the storage layout that we said before, but we might consider that it has other problems. So for example, if you have the logs of the remote chain, you're able to prove that a certain token transfer happened, but you might not entirely be entirely sure that it is the specific token transfer that you care about. So for example, if you are on chain B and you're waiting for some payment that happened on chain A in order to mint an NFT, you might see a transfer from the right address to the right address and for the right amount, but how can you be sure that it is the payment that you're waiting for, and that it is not some random unrelated payment that happened 2 weeks ago, right? So you don't really have all of the information that you might want from reading arbitrary logs. So more normally, what you're going to find in these cross-chain protocols is that a subset of the state or a subset of the logs is going to be made available. And so what's going to happen is that some specific contract is going to be designated as a bridge contract, and it's going to be sort of the entry point for this cross-chain communication. So in the case of the paying for an NFT, you're going to have a contract that processes the payment on the chain A, and then talks to this bridge to say, hey, the payment happened and it was for the correct amount, and this is the ID of the NFT that is being minted and the order ID and so on. And then this gets emitted as a log and sent, or not sent yet, we're going to talk about it in a minute, but it's going to be sort of registered on the chain state, and you're going to be able to authenticate it on chain B to prove that the payment, like the exact payment that you wanted, happened. And so this is going to be known as a messaging primitive. These little bits of these logs that we're going to be emitting are going to be designated as cross-chain messages, and they're going to come from the logs of this special purpose bridge contract. So what is contained in a message? Like when we send a message, what is the developer going to have to specify? We're going to have some basic things that we want. There's going to be a payload that includes the parameters, and obviously there's going to be some sender, right? We want to be sure that the message that we are seeing was sent by a specific account, which is like a very important piece related to the whole authentication deal. Now, these two things are the basic things that you're going to want, and this is going to have the shape of a broadcasting primitive. This can be useful. In fact, Arbitrum recently released a broadcasting contract that does exactly this, and it can be useful for a wide range of use cases. But normally, you want something that's a little bit more specific, because what you want to do is replicate the same chain interaction where you interact with a specific receiver, right? You send them a piece of information, you call a message on a specific receiver. So normally, cross-chain messages are going to have two more parameters, which are the destination, right? The chain where you're going and the receiver of the message that you intend. And so we could call this a point-to-point messaging primitive. And this is starting to look a lot more like the kinds of protocols that we know about, like Hyperlane and Axelar. They kind of have these basic sets of parameters because they're trying to replicate this experience that we have on the same chain on the cross-chain setting. Now, one thing that we probably want to add here that we shouldn't forget is replay protection, right? Like I said before, when you see, say, for example, a payment, you want to be sure that it is the specific payment that you're waiting for, and you also want to be sure that you haven't already processed that payment. So normally, these cross-chain messaging protocols are going to have a built-in replay protection mechanism that could be either managed by adding some nonce in the message, or more likely by marking certain specific logs as already processed in the system on the destination chain. Now, we have to consider now, we have this primitive of chain state authentication, and we are building on top of that a messaging abstraction. And so our source contracts on the source chain are going to be able to send off messages, and they're going to be able to say, well, I want to send this message to this receiver. But something is missing here. And it should be obvious that something is missing, because we know that chains are not free, right? We have to pay for the block space that we use. And so when you emitted the message right here, you paid for some gas to write the log into the state, but you are implicitly requesting for some execution to happen on the receiver. And you didn't pay for it, right? Because nothing in here, you just emitted a log. You didn't pay for any execution on the destination chain, and it's not going to come for free. So there is a little piece here, not so little, that we are missing to get the kind of experience that we want, that is usually called relaying, right? Once we have inserted this message into the state, once that we made it available to be authenticated, we want it to actually be relayed to affect some change on the destination chain. And so this is going to imply that we're going to need quite a few parameters more in our bridge to actually process this cross-chain message related to relaying. And so it's going to get a bit more complex here. So the one thing that we're going to need is, these things are going to be similar. The first two things are going to be similar to just sending a transaction to any chain. We're going to need to specify a gas limit, so up to how much gas do we want to pay, and we're going to have to say how much are we willing to pay for it. Now, both of these things are actually going to present a problem for the developer, not so much for the protocol, mainly for the developer. Why? Because the exact gas limit that something will cost, it can depend on many things that are dynamic, right? It can depend on the parameters. It can depend on whether some certain storage slots are warm or cold. And in some cases, you can have some sort of loop where maybe there's a bound, but it can be longer or shorter. And so the gas limit is not fixed. And so the developer is going to have to specify something. You're going to have two options here. You can make your source smart contract right here fix some gas limit that they're willing to pay. And maybe you can compute some upper bound on like how much it's going to cost to process the message on the delivery side. Or what you can do is also to just, allow the end user that is off-chain, that can estimate the gas that it's going to take to process the message on delivery, to inject it as a parameter on the transaction. So like the contract is just going to say, hey, I'm going to trigger the message, but you can tell me how much of a gas limit I should specify based on your estimation. And then we're going to have to specify the gas price, right? We're going to have two separate chains. They're going to have different gas markets. So the price is going to be different on the source chain and destination chain, right? So we need to specify it. And we can't just ask like, okay, tell me what the gas price is on the destination chain, because this again requires cross-chain communication, right? You would need to read cross-chain state, and this is kind of circular, right? It's what we're trying to do. So again, here you have the option of just allowing the end user to inject it in their transaction. They're off-chain. They can observe both chains and just say, all right, send this message and you're going to have to pay this much price. Another option that you have is to have some sort of oracle where some party is observing the chain B and injecting the gas price of chain B into chain A for the execution layer to use. And that's quite common too. Now, both of these things, you're making estimations. Even the oracle might have a bit of a delay. So you have the risk of overpaying, right? You might go on chain B and execute deliver the message and execute it and all, and have a little bit of surplus. So another parameter that you want to include in your cross-chain message is some refund receiver, where whatever was left over from the gas, you refunded to the sender on the destination chain. You could try to do refunds on the source chain, but this starts to get really complicated. So this is the simplest thing that can be done. And lastly, you also need to consider that the gas token might be different on the destination chain, right? So this is not exactly a parameter, but something to solve. And finally, we need to think that we're going to be relying here on a relayer that is a third party to observe that the message was emitted and take it and submit it on chain B. So it's going to be a service that they're going to be providing, and so we're likely going to have to pay a little bit of a fee for that. So this is starting to get complex, but if you want to try to approximate what you had right here with multiple chains, you certainly have to think about all this. Now, this can actually fail in some ways. That is important to consider, and will also have an effect on the API that we design. Why? Because as we said, right, we had to make some estimation here for the gas limit and for the gas price. And we said there might be a surplus that might have to be refunded. But also what can happen is we may not have specified enough. And so we're going to have a failure mode where the gas limit or the gas price that we specified was not sufficient. And so we're going to need some sort of API to allow the sender to maybe top up the gas or to somehow manually retry the submission of the message on the destination chain. And we might want to consider that if they never do that, do you want the message to just sit there waiting to be retried, or maybe you want to set some expiration timestamp and include that in the message by default. Now here, what I wrote also is that the execution of the message delivery could could fail and revert. And this is not necessarily a problem for the message protocol, the messaging protocol itself, because it can just consider that it successfully delivered the message and that the fact that it reverted was an application problem. And I haven't checked, but I believe this is probably what most protocols do. So the thing that's important to know about this is that when you are designing a cross-chain application, you have to make sure that you never revert on the processing of a cross-chain message, or that you have some clean way to recover from that. Because in the worst case scenario, there may be not only information that is never delivered, but potentially assets that end up being locked. So putting all of that together, we might end up with an API on the bridge on chain A that looks like this. Your request to send a message, specify payload, destination, chain, and receiver, and then whatever parameters are needed to actually get that to happen on the destination chain. And so any protocol that you see that does cross-chain messaging will probably have something like this. And these are the reasons why. Finally, one thing that I want to note, it's very important, is that observability here becomes really crucial. This, we're going to have quite a bit of asynchrony here between, sending the transaction, getting it included in the source chain, getting it processed by the cross-chain protocol, then getting it included on the destination chain, and so on. There's going to be quite a few intermediate states from the message having been sent to maybe it's waiting to be, it's been authenticated and it's waiting to be relayed, or maybe it was relayed and the relaying failed and you need to retry it, and so on. So there's quite a bit of information here that we want the user and the application and the wallet potentially to become aware of, that is not obviously included in a normal explorer like Etherscan, because it's not aware of everything that's going on. And so this can really harm the user experience. it can be really common to try to, or at least at some point, to try to transfer an assets to some other chain and feel like you're shooting them into a black hole and just waiting until seeing them show up. And it can be really a terrible experience. And this is because these systems are so complex, and they didn't have the right observability mechanisms built into them. But it is a very important thing to include when designing them. So these are the things that I wanted to share. Hopefully they're useful to understand the cross-chain protocols that you're using, or as input into whatever cross-chain protocols you design, or whenever you design an application and use one of these in them. Thank you. Thank you, David.
Awesome. Yeah, look at that comment. Great comment.
I want to mention oh, thank you. I used, I think this is a great resource. It's a little bit academic, but a lot of the information that I just described, you can find it here. And you can find.
Can you drop the URL in the in our private chat, and I can get up on screen.
It's a really great report, and
it was
a lot of what I said, you can find it here.
I love like how you structure the section. How I don't know if we were using a mirror or what exactly this tooling, this boarding.
This is TL draw.
Oh, TL draw is like TLDR.
Yes.
On that. No, it was great. Maybe if we can like export this as a PDF just to share like with hackers after, would be amazing.
I'll send it to you guys.
Yeah, I don't know if we have much questions on the YouTube channel. I know everyone was loving it. I know we are kind of running a bit behind for the next section as well, right, Wit? So I don't know if you have any question for Francisco, or if Francisco wants to give like the last words of consideration, and then we move for the next section.
Yeah, that works. Yeah. If you have Francisco any closing remarks, then that's awesome. And tell people, if you want to, like how they can ping you with questions or reach you, or if Twitter handle or.
My Twitter handle is @frangio _. Happy to open for DMs there. I don't have anything else to add. I think I got it all out there. So I'm glad you all enjoyed it.
Awesome.
Thank you so much.
Yeah, thank you so much.
Thank you.
We'll get Kanishk on from across now. Here we go.
Hello,
right,
hello.
Francisco, I'm going to move you off stage.
Kani, do you have any question for Francisco? Sorry.
Sorry, I'll put him back.
No, I don't have any questions, but I really thank him for that masterclass.
Oh, I know.
Even I'll refer to it, and especially the GitHub repository that you've shared, gold mine, honestly. But yeah, thank you so much.
Sweet. All right.
Thank you.
All right. You share your screen if you are able, Ganesh, and I will get it.
Yeah, absolutely. I'll get started.
Yeah.
All right. So I think there we go. Hello, everyone. My name is Khurana, and I'm a DevRel at Across. Today, I'm here to talk about intents, and I'm also here to talk about how you can win the Build and Brew hackathon. There's a lot in store for us today. And before we get started, I'll just check if my setup is set up correctly. And it looks like we are doing good. Perfect. So today, we are going to talk about a couple of things that are on the agenda. We have already discussed intents in depth. I genuinely don't think that I can explain it any better than the team from Hyperlane, the team from BootNode, or the team from OpenZeppelin. I really thank them for taking that time and building that segment of this particular workshop, because now I can skip and we can go straight to building, which is something that I love doing. So in this particular section, we can talk about very quickly just about intents, just to set the stage, right? And then we'll move on to the app SDK and the APIs, which will help you build full stack cross-chain applications that are production ready with Across from day one. And then we'll also walk through some sort of a sample app basically that I built, which will help us make sure that the integration of the Across SDK into your project is correct from the get-go. And I'll also walk you through a very famous framework for building applications, which is Next.js with WAGMI and Tanstack. And then, of course, VM is my favorite utility to use. So I'm going to walk you through some important factors of this particular package and some utilities that it comes with so that you can integrate them and you don't have to go through the hoops of finding the best fit for your application. I'll give it to you right away so that once this particular workshop is done and you sit silently in front of your system, you should be able to code and finish the across segment of your product as quickly as possible. Because once you're done with the basic integrations, that is when we really start cooking with a lot of fire. Because then we can head over and talk about embedded cross-chain actions. And then, of course, I'll drop in some resources and requests that people have had over the past to make sure that the hack and the builds that they're doing are successful. With all of this said, I'm extremely excited. I have my eye ready on the private chat in case you have any questions. I'm sure the team will relay those here. I'll also just quickly open the comments. And we have a lot of our community members here. Hi, Benjamin. Hi, Infinity. Thank you so much, everybody, for all the love and support. Let's get started. First things first, what's an intent? Let's start from a very high level understanding of what an intent is. It's simply a part of our day or a part when we desire something, and we don't have to think about the path to achieving that. And that is something that we are able to execute on chain. A broken definition, but let's start filling the gaps here. When we come on chain, an intent is basically a type of an order where a user just comes and tells us, hey, I have X amount on chain A. I want this X amount on chain B because I want to do this particular action. It could be minting, it could be staking, it could be depositing, or it could just be checking out a new DEX or a lending and borrowing protocol. It is our aim that the user should be able to get there as quickly as possible at the cheapest cost possible with all the security that we can provide them. And therefore, this is where intents become absolutely useful. And this is why we use them in production. So now with all of this said, we've already walked through a lot of fundamentals and theory about intents. But in case you have any questions, concerns, or problems, please put them in the comments or in the chat, and I'm going to make sure that I address all of them properly. Moving forward, now I've explained what intents are. It's time that I walk you through the documentation around the app SDK and the APIs. We've recently revamped a part of our developer documentation, so I highly urge you to check it out and give us some feedback and tell if it is useful and tell us what more do you want to see here. Now moving forward, if you are more interested beyond what I just explained in terms of intents, you can check out the what are cross-chain intents section of the documentation. And we also want to make sure that we check out ERC7683's own site, which has the standard listed right here. So you can go read, understand what the mental model for a person should be around intents, right? What is the timestamp by which your order must be filled? What is the order data type that you must send, and what should be the entire data that you're porting through? So all of that is also a part of the documentation right here, but we'll come back to it in just a second, because for the builders and the hackers sitting with us today, all the fun starts here at the app SDK reference section. So to make sure that all the builders are able to integrate across into their applications, and no matter what your application is, right? It could be a wallet, it could be a staking protocol, it could be a lending and borrowing protocol, it could simply just be a UI in which you want to show how across works, and even that is very appreciated. But yeah, it could be an NFT minting platform where it's actually cross-chain NFT minting. So your users can come to your collection, but they don't have to worry if they have funds on your particular protocol or your chain or not. They can simply click on mint, and it is a cross that handles bridging the fund over to the chain that you're on and then minting. So it's not that difficult to do. And today we're going to make sure that we cover the fundamentals here. We walk through a demo application and we move very swiftly throughout all of it. To get started, the most important thing here is heading over to NPM and installing the Across Protocol App SDK package. This particular package comes with 3 important steps. Let's quickly look at them and ensure that we have the fundamentals set up properly. First up, you want to make sure that you set up the SDK in your application. To do that, simply use the create across client function that we provide. And all you have to do here is provide an integrator ID if you want, and the chains that you want to support. As soon as you mention the chains that you want to support, you will be able to use these chains like so. And I'm going to make sure that we come back to this in a second. So once you've set up the client that is going to give you the supported chains, that is going to give you the code on the protocol, and that is also going to execute this particular code for you, we then move forward and we make sure that we set up a function which is going to bring this code to us. But Kanishk, what is a quote, right? This can be a question that can come to you. And the simplest way to answer it is to actually show you. This is the production application for Across. If you go to app.across.to/bridge, this is what you will see. This particular platform has been used to support over, I think, about 20 billion in transactions. So that is absolutely insane. And now let me just show you what a quote looks like. If I were to go from, amount is too low. I know why, because the minimum here is $10. Yeah, so here we go. If I want to go from Ethereum to Hyperliquid, which is, and I want to bridge, say, $15, this is my quote right here. This is the total amount of output fee or about output amount that I will get on Hyperliquid. It will take 18 seconds. It will cost this amount of money in like fees, right? If I switch this and I want to go from Ethereum mainnet to base, we're going from an L1 to an L2. The amount is quite similar. But if I go from Arbitrum 1 to base, see, it takes 3 seconds. That's it. So when people say Across is the top UI UX, this is what we mean. It takes 3 seconds. Anyway, now we know what a quote is, right? So this is the fees, this is the total amount, this is input amount, this is output amount, and these are origin chains and destination chains. Now coming back, this is exactly what a quote is. Your origin chain, your destination chain, the input token address for that particular origin chain, the output token address for that particular destination chain. Once you define all of this, the only thing you want to mention here is the amount you are sending over. Since these are WETH values, we're going to use parse ETH. If you don't know what parse ETH is, it actually comes from VM. Now it is the perfect time for me to segue into VM and literally talk about these utilities that I'm an absolute fan of, simply because they make my development life so easy, right? All you have to do is just install VM, and then we are going to head over and we're going to go to parse units, which is present right here. So basically what parse units does for you is that when your user will come on your particular front end and they will mention the amount, you don't expect them to go to the last decimal place for that particular token. That's just bad UX right there. So with parse units, you can fetch the decimal value for that particular token, which is what Across the app SDK will provide you. And then simply just make sure that you pass this over when you are submitting the code. Essentially right here. Now, once you have the code ready, once you have set up the client properly, the only thing that is left for you to do is to execute this code and make sure that your user can bridge funds from chain A to chain B, from origin chain to destination chain. Now let's look at execute code really quickly, and then move over to the application that I have that will demo it all for you in a very swift manner. And of course, if you have any questions or confusions throughout this process, feel free to drop a comment, and I'm going to make sure that I address this as quickly as possible. All right. Now, when it comes to executing a code, keep in mind that this is where you will be signing transactions. This is where you expect the user to interact with whatever wallet they have connected to your application and actually go through with the bridging transaction. Therefore, whatever wallet client you set up needs to be put in here so that we can actually call it. It is my suggestion that when you use WAGMI, you use Rainbow Gate, you use Privy, you use Web3 React, or whatever other library that you want to use. But make sure that you set up the wallet client in such a way that WAGMI can fetch it, so that we make sure it's a part of the WAGMI config, and it can then move forward. All right. And again, if this is something that you're not familiar with, do not worry. We can discuss this later, and I'm going to share more resources around where you can get help if you are stuck. But let's get to that later. Again, moving forward, then you just deposit the quote here. So when you are going to be passing the quote right here into the execute quote function, deposit is going to be a part that you get from get quote function, which we call right here. And then it is there will be 3 steps that will happen right after execute quote is called. First one is approve. The spoke pool contract needs to be approved to spend this token on your behalf. Second, the deposit will happen. Now, deposit is the first part in our process here. Basically, money from your account or money from the user's wallet is going to go and get deposited, which is when we will acknowledge that user has submitted $10 or 10 USDC on chain A, and they want 10 USDC on chain B, and they will get filled. So the user deposits first and gets filled. And that is how a cross-chain app is successfully built out using intents. And that's basically it. So you first approve the contract to spend on your behalf. Then you deposit the funds, which is successful, and then you move on, and you are filled, which is when you receive funds on the chain you are requesting. With this said, it is now time that I show you how an application like this can be built from the scratch. As you know, my session is called building a cross-chain application on Next.js using the Across App SDK. Keeping the time constraints that we have in mind, I have already cooked a sweet, cute little application that we will be using today. Let's get started. The first thing that you want to do is just make sure that you set up a Next.js application. Now, I personally use ShadCN for all of my setup right here. So ShadCN provides me with some utilities, some styling, some things off the bat that I really don't want to spend more time on, especially when I'm in a hackathon. And in all of my Web 2 and Web 3 hackathon experience, I have noticed that once the functionality is done and the app works, styling is something that is an iterative process. And ShadCN is the easiest way for you to get there. All right. So I move forward, and the only command that you need to pay attention to start off is this one right here. So we will copy it once again. And as you know, all you have to do is trigger your terminal and just paste it like so. Now, since my server is already running, I don't need to install it all again. And as you can see, I already have it right here. So we are going to continue the process now. And there we go. All right, so as I mentioned, the first thing you want to do is set up the Across client, which is this part right here. Now I'm using React context here. So I'm just going to create a context, wrap my entire app around it, and then move forward. If you're comfortable with this flow and you have done this before, that's great. Move forward with it, and we can keep continuing our building process. If you're not comfortable with it, what you can also do in a very beginner fashion is take this particular client and just call it on top of the file where you will be calling all the functions. And then you can just use the same client each and every time without using any kind of context. And that will at least make sure that the integration of the SDK is done. And we can make it more performant later. And that is absolutely not a problem. Just hit us up on our Discord server. We've got the Espresso Discord server, which is completely optimized for this hackathon. We've got the Across Discord server. We've also got Twitter. So let's keep going. First things first, just export or import create Across client, make the client like so. And as you can see, I've literally just copy pasted the code from here. And next thing I've done is I have made sure that there's a use across function, which I can put in any component that I want, which will take the power of this particular provider and make sure that I can use whatever I want from the Across SDK. Let me show you how that works. The most important thing that I want to highlight here is that Across has a very, very good utility. And this particular utility is called, I think it's called Get Supported Chains, which means that with the Across App SDK, you can get all the chains that we support. So do you see this nice little drop-down menu? Yeah, I did not create this myself. It came with the SDK. All I did was fetch it by making a function call and just display it on the UI. This is so good. This is so cool because you get the name of the chain, you get the logo of the chain, you get the chain ID. You also get all the input tokens on that chain, and you can also get all the output tokens on that chain. And see, it is dynamic. If I change the chain to linear, for example, I get a different list of tokens. I change it to scroll, I get a different list of tokens. So it is extremely dynamic and really, really fun to mess around with. Now, how that works is that you go to the use supported chains, right? As you can see, I have imported the use across function from the across context that we had created, which is literally what I showed you just a couple seconds ago. And here is the use across function, which is simply just giving me the across context so that I can use all the functions that the across app SDK provides me. Moving back, in the supported chain section, as you can see, all I'm doing is calling the across SDK and then calling this function, which is just get supported chains. Get supported chains does a lot of things internally that you do not need to worry about. But the cool thing that you need to focus on here is the fact that you get all of this ready. And all you have to do is call one function. Keep in mind, all the other parts of this particular file, which is the query key, the query function, this is all because we are using TanStack React Query. If you're somebody who's not comfortable with it, feel free to skip it. It does not matter. You can use whatever framework you like. Hell, you can even make use effect calls, which is something that we have seen in a lot of code bases. And if you can make it work and your application works, it's great to get started and continue with this hackathon right now. Now, moving forward, once you get these supported chains, you can simply just put them in a UI. My UI will look something like this. So as you can see, all I'm doing here is calling the use supported chains, which is the function that I just showed you. As you can see, return sdk.get supported chains. And right here, I'm also console logging supported chains. Now, this is cool. Let me show you what a console log here can look like. And I'm going to filter my console log because I know I'm going to have a lot of things there really quickly. So I open this, I go to the console. As you can see, I'm getting a lot of things here. And let me just expand one of these, all right? Of course, we can work a little bit on the management of the performance of this application, but look how cool this is. You get the chain ID, you get the Explorer ID. So once you do a transaction, you can give a view transaction button and use this right there. You get the input tokens, and I'm going to zoom in a little bit here. There we go. This is perfect. You see, you get the input tokens with their addresses, the decimal values they go through. So remember when I showed you VM, and I said that you can use the decimal value here along with the number that the user inputs. This is exactly why I told it to you, because now you can use decimals that we provide you along with VM and have a very good user experience along with it. The logo URL, in case you want to use it here or at any other part of your application, the name and the symbol of the token as well. Funny enough, you also get the output tokens. So which tokens can the user come to this particular chain with, and which tokens can they leave from this particular chain with? Both are presented to you. And finally, a public RPC URL. So you don't have to go to other providers and find a URL to take these transactions forward for you. We do it for you. And of course, the spoke pool contract. This is the contract that you're approving as a spender. Awesome. Now that I've walked through this one particular utility that I absolutely love, I can actually show you what getting a quote looks like in the across app SDK. I have another hook for it, which is called use quote. Simply just used to get a particular quote. Similarly, just like we used use across function previously, we're going to initialize the SDK again. And this time we are going to get the use quote. We're going to use the use quote hook to get the quote. And in this particular file, all I'm doing is just calling one function, which is the get quote function. If you remember from the NPM example that I had showed you, the get quote function just needs the route, which is origin chain, destination chain, input token, output token, along with the amount that you are entering that you want to bridge. The params that I have mentioned here do exactly that. And this is also something that you can get as like a utility from our SDK. So you can literally just copy paste this code in case you're using TypeScript, and it will also work for you. But yeah, that's majorly it. You don't have to follow this. You can simply use JavaScript and move forward in this fashion as well. Or you can define your own strings, and that is also valid. Now, once you get the code, this is where the fun starts. Because use execute code is a hook that I've created here, which is going to make sure that when you run the execute code function right here, you are able to follow the process that we've defined already. Please keep in mind that this is where you need the code.deposit attribute from the use code hook, which is right here. So here it is. See, this will return a quote to you. In this particular quote, you will have a deposit object, which needs to be passed right here. And if all of this is getting confusing for you, please do not worry, because we have an entire example that you can look into, and I'm going to share that with you in just a second. And you can follow and make sure that all of this works for you. But essentially, just pass in the parameters, give it the wallet client from Wagmi, and you're good to go. Once you're done, this is what your UI should look like. So as you can see, I have a demo value everywhere in this. You need to just put in a connect wallet button. If I go from Ethereum to, I like OP, so I'm just gonna go to OP really quickly. I'm gonna reload and OP will show up. I go from ETH on OP to ETH from Ethereum 5, and you can see some values pop up. Obviously, we need to work a little bit on it, but values will start popping up, and you can get a code right here. All right. So yeah, this is a very, very high-level walkthrough on what your integration with the SDK should look like. Do not make mistakes like me. Make sure that you use the correct values everywhere, and you use VM as something to support you while you're building this particular process out. Before I move forward, if you have any questions, now would be a great time to point those out. I have like 5 minutes left, and in that time period, I want to make sure that I walk you through the API references that we have. To make sure that your development process is as smooth as possible, you can get all the fees from one chain to the other using the suggested fee API. If you want to see the limits of the system right now, by limits, I mean how much money can I deposit? What is the smallest amount of deposit that I can make? What is the smallest amount of delay that I will have? Or what is the amount of money that I should give to the system so that I can quickly make that particular bridge transaction in the shortest time possible? You get all of that information using the limits endpoint. As I said, this is an endpoint that will give you the maxima and the minima of the across protocol for a particular token and a chain right now. Then if you want to see the available routes for a particular origin destination chain combo, or like a token combo, that's what you can see here. And finally, if you want to see what is currently happening to your deposit, keep in mind deposit is when money comes from you. Fill is when money goes to you, when the bridge is done. Now there are a lot of statuses that can happen here, right? When your bridge transaction is complete, you will be shown the status of filled. If you're still waiting to be filled, but you have deposited successfully, you will get pending. If your fill deadline has expired, you will get expired. If it has expired, you will also get refunded within, I guess, 3 hours or like 90 minutes of you making that deposit. And if it is a bigger amount and the cross reeler needs to hop in and make that particular fill, slow fill requested will be visible right there. So this is how you can track what is currently happening to your particular deposit. Now we have covered the SDK, we've covered the API reference, we've seen a very simple demo application. If this is something that is confusing to you, we can do a larger workshop around this. And I'm going to hang out in the Espresso Discord and the Across Discord to make sure that all of you are building with full speed. The last thing that I want to talk about here is across embedded actions. Just integrating the bridge, as I mentioned, is the first part of the puzzle that you have solved. With this, congratulations, now you're in the race. You've integrated across. You're up for that 10K prize pool. How do you take it a step forward and actually make sure that we look at your project and say, wow, this is amazingly built. Let's give it an award. One of the easiest ways to do that is check out what embedded cross-chain actions can do for you. This is when you are able to bridge but stake, bridge but deposit in the same flow. So under the hood, your user does not know what's going on, but you have built a layer that is extremely, extremely fluid. I'm going to walk through this a little bit quickly because I know I have less time, but stay with me and ask questions if you have any. We have a contract called the multi-call handler. With the multi-call handler, you can pass in a message along with your bridge transaction that is going to make sure that once the bridge is done, the second action that the user has called also takes place. In this particular sample that is in front of me right now, I have created a JavaScript example for you so that if you're comfortable with JavaScript, you can use this. If you're comfortable with Solidity, you can use this. Literally what you have to do is copy paste this on Remix and you will get a message, which is going to be a hash. And all you have to do is take that hash and put that in the bridging transaction. But that is something we can discuss separately as well. But here's what basically will happen. Once the bridging transaction is done, money from the user's wallet after the bridge is also going to get deposited into the Aave contract. And that is basically what we're trying to demonstrate here. If this is something that is boring for you and you want to move one step forward, I highly, highly appreciate and support that. And what you can check out is the second example we have, which is when we wrap a choice, right? Now, this is going to give a user a choice between what they want to receive, WETH or ETH. Next up, if this is also boring for you, charge the protocol fees, my friend. Go forward, do something absolutely crazy, and show us the skills that you have as a developer. The fundamental here is exactly the same. With the bridging transaction, you're sending a message, which is going to be the second thing that will happen once the bridging is done, once the funds on the destination chain have arrived. Finally, I think we have one more example here. But we don't. Okay, cool. There it is, Uniswap swap. So you can create a transaction for a Uniswap swap as well using this particular sample. And if the multi-call handler does not suit your use case, and you say, Kanishk, I'm just not able to figure out the most optimized way here, that's all right. You can go and make a custom handler contract as well. We've shown how messages can be crafted right here using JavaScript and Solidity once again. But we've also shown you how you can implement this particular contract. All right. But make sure that you do your own set of testing here, you do your own set of due diligence here to make sure this is absolutely possible and well available on the production mainnets. But that's basically it. Make sure that you as a developer, you are exploring the embedded cross-chain actions section and building a UX that we can look at and be like, wow, this is amazing. We want to give this a shout out. And yeah, with that, we've mostly covered everything. ERC7683 is something that we have co-authored along with Uniswap, and it is something that we are pushing hard so that it can become a standard for cross-chain intents on Ethereum. And we can expand this to make sure that users of this ecosystem can feel that this ecosystem, even though it has so much fragmentation, so many L2s, so many tokens, it is essentially just one ecosystem that we are using across all applications, no matter whether it is Base, Arbitrum, Optimism, or any other rollups or L2s. I have already mentioned very briefly about the mental model that a user should have when they are dealing with intents. And you as a developer, when you're making these interfaces, make sure that you also keep it in mind. Again, really quickly, fill deadline is the last amount of time or the amount of time in which the cross-chain intent should be filled. And if it's not filled by then it expires and the user is refunded. Refunds are handled by the protocol. You do not need to worry about that. But only on the mainnet. On the testnet, we do not provide refunds. Order data type, it is an EIP712 type hash, which is, I think, for messages and signatures. And then the order data. Again, order data is just parameters, the tokens, the amounts, the chains, who will receive the funds on the destination chain, etc. And basically, that's it. Follow this particular guide. I assure you that this is production ready end-to-end. You can find out the contracts on Base and Arbitrum. The sample that I have put in here is going to go from Base to Arbitrum. And what I've shown here is taking $10 from Base to Arbitrum in USDC. If you're somebody who wants to take this ERC7683 in production documentation, make a front end for it, that is absolutely amazing. You can also take references from the front end that we provide to generate an intent. We do this using VM, and you can very, very easily follow this yourself and make one on your own. I'm going to quickly show how this works once again. For those of you who missed it when I had displayed it previously, all you have to do is come here, put in the wallet address that will be the recipient address. And also in this case, it's going to be the address that is going to send the tokens or deposit the tokens. So make sure it has whatever amount you're depositing on the destination chain, or sorry, on the origin chain, which is base. Destination chain is arbitrary. Here you go, 10 USDC, generate the intent. Here you go, the intent is generated. Kanishk, this is so cool. How did you make this? You can find the entire intent generation code base here. It's in VM, just copy paste it and you're good to go. And finally, execute this in your own way. With this, we come to the end of most of my session. I do actually want to share one thing really quickly, which is what is expected out of you and what makes you shine as a developer. First things first, use embedded cross-chain actions, which we've already talked about. Bridge and mint, bridge and deposit, bridge and stake, completely up to you. We just want to see how creative you can get and how much we can support. One thing that I've seen a lot of people request, and I myself would want to use, is multi-input output token bridge, which is when you can select which tokens on what chains are your origin, which tokens on what chains are your destination. So you want to receive those tokens. And in one go, your user is able to select all of them. In one go, they receive all of them. Now, one caveat that I think here as I talk through, which you might experience, is you'll have to sign multiple transactions. But be creative and let's figure out a way around it. So that we can implement a multi-input output token bridge. And we would love to reward you a very heavy amount for this because we know there's a demand for this in the market. Finally, agentic bridging. AI agents haven't lost their hype since January. And we want to make sure that we support this narrative and allow agents to take over bridging as well. Therefore, if you can implement agentic bridging using ELIZA, Goat SDK, Freyja, which is, I think, a fork of ELIZA, or not a fork, but essentially an imitation. Anything that you can build with AI agents and across app SDK is super, super appreciated. And I want to see you all win with those applications. Keep in mind that this is a list that is not exhaustive. There's no end to the ideas here. And therefore, whatever comes to your mind is something you can create and we will support you. But do talk about your ideas. Get some mentorship around it to make sure you're creating something that is absolutely needed and not just reinventing the wheel in a different language. If you haven't checked it out already, we have a lot of ideas that you can build here as well using the ideas to build section on Dora hacks. And you can essentially put a cross in almost all of them. Cross-chain NFT marketplace, hell yeah, we talked about it. Talked about this in the start. And this will be a very, very nice and an easy build for you, especially if you're using embedded cross-chain actions. Wallet UI integration, go ahead, take MetaMask snaps using Flask, add a cross to it, and let's go. Finally, with this, I think I am now at the end. So anybody who is interested, reach out to me. I'm super duper happy to help you out. Join the Discord server. Check out the documentation at docs.across.to. And most importantly, all the best. And I want to see all of you win. Let's get it. Thank you, everybody.
Oh my God, that was an amazing session, super inspiring. And all the questions that I could have had, you already answered. I was supposed to ask you, like, what are you expecting the builders to build? Like, what you're seeing as cool projects to build upon open intent? That was amazing, Kani. Thank you so much.
My pleasure.
Yeah,
Thank you.
That was awesome.
Much.
Thank you so much. So let's see. Quickly, just go over.
Yeah.
There you go.
Perfect. Thanks. Wait, Kani, if you want to stay with us, we're just wrapping up as well.
Absolutely.
First, I wanted to thank all the speakers that were here with us. Infura, Gabriel, Eda from Hyperlane, Fernando and Lisandro from BootNode, after Francisco from OpenZeppelin with the masterclass, after this last session we had with Kani as well from Across. I think was a great session. Everything is recorded. We're going to do some cuts and have a playlist so everyone will be able to rewatch again and even share with friends. Final closing remarks here in important dates. So Today was a workshop day. I think every dev, every builder has all the toolings needed to start like the projects, from deploying the Arbitrum rollup to now being able to build these cross-chain apps. We do have the office hours, as we already mentioned. Espresso has office hours, BootNodes. Kani will be in the Discord as well, and Kani, feel free to just share like your office hours, or even like across Discord, feel free for. I would suggest keeping everything at least in the channels of Espresso, just for the hackathon purpose. We have the final submissions on March 31st. So you have pretty much 19 days? No, 18 days to build. If you need to find your team, you can find on our Discord as well. So if you're struggling with it, just call us. We can try to help you with that. And after the final submissions, we are gonna have like just 1 week of time to choose the projects that's gonna go for the pitch day. You're gonna have notice a little bit before, like at least 3 days before, to prepare for the presentation on the pitch day. And then the winners announcements on April 10. With, if I forgot anything, please feel free to compliment myself.
No, you're all good. That's all good.
So
Yeah,
then,
you.
thanks everyone. Thanks everyone.
Yeah. Thank you, everyone. Thank you, Kanishk. Thank you all the speakers. And yeah, we'll see you in the Discord. We have office hours on Friday. You said that, right?
Yeah.
Office hours tomorrow. Cool. All right. I'm going to go ahead. Is there a question? Yeah, cool. All right. I'm going to end the stream. Thanks so much.
Thank you all.